Okay, so good afternoon. Welcome to Django in Depth. My name is James Bennett. Hopefully you're here to learn about Django, and I'm going to actually, is there any way I can move this a little bit so I can stand like facing straight instead of like facing that way, or, okay. Okay. So, as we have people sort of wandering in, let's go ahead and get started a little bit with a little bit of introductory material. This is an intermediate level tutorial, so hopefully those of you who are in the audience know some Python. Hopefully you know some Django. My recommendation is you've at least done the tutorial. Ideally, maybe read a little more of the documentation beyond that, but at least have some basic idea of what's going on in Django. And you're here because you really want to understand in a deep way how all of the parts of Django fit together. Luckily, you are here with me. My name is James. I've been working with Django for about 6.5 years now. 5 of them I spent at the Lawrence Journal World, which is where Django was originally developed. I have a commit bit on Django. I'm the release manager. My GPG signature is on the releases that you download. What we're going to do in this tutorial is basically Django from the bottom up. A lot of tutorials, and the first time I did this, I wanted it to be this approach. A lot of Django tutorials will start very high level. They'll say, okay, here's your model, here's how you do your queries, here's how you build your website. And this is nice because it gets you productive really quickly, but doesn't necessarily teach you how everything actually works. We're going to be mostly starting at the low-level guts of Django and working our way back up to the things you find in other tutorials. We're going to give you a deep as possible understanding of how Django works, deep understanding of how each component of Django works. Hopefully when this tutorial is done, you will be able to explain to someone how the ORM generates a database query. We are also going to do some bits and pieces of undocumented API. I will try to point out when I'm covering something that you can't necessarily rely on as being stable API. But for the most part, anything that Django documents officially is going to be stable. Anything we don't document officially is unstable. There is in the documentation an explanation of what parts of Django are considered API compatibility policy and what parts aren't. We are also going to talk about the way things are in Django 1.4. This version of the tutorial was written from looking at recent trunk, which means me yesterday on the plane with the 1.4 release candidate checked out. So this is going to be as up-to-date a Django tutorial as you can get anywhere in the world right now. A couple things we're not going to do in this tutorial. This is not beginner level. Like I said, hopefully you've already done the Django tutorial. If I start talking about the ORM and models and queries and templates and things, hopefully you're not too lost, because if you are, then you're going to be even more lost very soon. This is not an API reference. I am going to go over a lot of Django's components, a lot of specific methods and attributes and how they work, but Django's documentation is the official API reference. If that's what you want, turn to that. We are also not going to be writing any code at all. I'm just going to stand up here for about 3 hours and talk at you about Django and let you ask me questions. So, that said, let's get started. We're going to talk about the ORM, the Django Object Relational Mapper. This is probably the most mysterious and most complex component in all of Django. It also is most of the code. So let's look at an example. Everybody probably has done something similar to this. This is a basic, weblog entry model. It's got a title, it's got a date, it's got a body, it knows how to represent itself. So Django can do this really neat thing where you take that model, you import it, you type this little query, Django turns it into that little query, and then Django turns it into that little result. It's a very deep and magical and mysterious thing, and the question is, how does Django do that? The answer may surprise you. This is my one obligatory funny internet image, sort of poking fun at the fact that a lot of the code in the ORM was written by Malcolm Trednick and Russell Keith McGee, who are indeed from the land down under. I shouldn't make fun of him too much because Russ is actually Dr. Russell Keith McGee. He has a PhD in artificial intelligence. He is an actual certified mad scientist, and he will come after me for this. So let's look at how it actually works in every level of detail we can go into. When Django is doing a database query, there's this whole series of things that are involved. There's a model class, there's a manager class, there's a query set class, there's a query class, there's a SQL compiler class, and there's a database backend. These are all of the things that are involved in just doing a basic query like get me all the entries in my weblog. So let's start at the bottom. Database backends. There's at least one database backend module in Django for each database that we support. These obviously live in django.db.backends. There are also some third-party ones out there. IBM has a database backend to support their DB2 database. I think there are at least a couple others floating around. Out of the box, we support Postgres, MySQL, SQLite, Oracle. I believe there's an experimental MS SQL driver running around out there. This is, when you're filling in your settings, what you put in the engine portion. Basically, this is where we're going to get the lowest level behavior, and this is going to be the boundary where Django stops. Beyond this level, your database queries are going into probably a compiled from C module like CX Oracle or PsychoPG, or the SQLite library in the Python standard library. This is where Django hands off. This is the last bit we do. Made up of a bunch of different classes. All of them have very specific names, so that when Django is importing your database backend, it knows to look for these classes with these names. First one, most important one, is called database wrapper. This is basically how Django is going to get a connection to your database. This is going to get us a PsychoPG database cursor or a CX Oracle database cursor or something like that. This is where our transaction management lives. This is where there's going to be a map. You can actually go look, like I think in the PostgreSQL PsychoPG2 backend in Django itself, you will see a little dictionary that has a list of all of the lookup types that the Django ORM supports on the left-hand side. On the right-hand side is a list of all the SQL operators in Postgres that those correspond to. There's one of these for every single database. Next class we're going to run into is called database operations. This is the one that is where all the fun code lives to support what your database does. This is where we find out how to generate your database's specific dialect of SQL. So I've got some examples there. This is where we do typecasts. This is where we do data definitions. This is where we learn how to quote things. This is where we learn what your transaction syntax is. You can also in here plug in an alternate query generator. I wouldn't do it here. We're going to talk in a minute about a better way to get that. Another class is called database features. Basically, this is where we find out what things your database supports. Django cares a lot about this. We need to know how you handle types. We need to know how you handle nulls. One of the most important things is if we're giving you empty strings or empty values like that, do you consider that equivalent to null? We need to know that so that we can generate queries properly. There's a database creation model. Anybody want to guess what this does? When you run manage.py syncdb in the tutorial, this is what we're invoking. It knows how to create your database, knows how to create your test database. You will find another handy little dictionary in there that tells you for a given Django field type, what is that database's native column type for it. There's also a database introspection class, which does the opposite. Has anybody here actually used the inspectdb feature in Django? Okay, a few people have. It's a really cool thing. Basically a command that you can run so that rather than writing your models and creating your database, you take your pre-existing database and run this command, and Django tries to spit out a list of models that correspond to that database structure. How we do this is the inspectdb command. It uses our database introspection class. This knows whatever your database's internal API is for getting lists of tables. This knows how to map your database's column types back into field types. And actually, this is a little different from the mapping in creation. because most of these databases, the APIs actually return internal identifiers or some internal constant to tell us what type of column it is. So we don't just simply have, text column becomes text field. It actually becomes like, column type 43 is text field. So that's where you'll find a mapping of that for your database. This may be handy if you ever need to introspect a lot. Also, on databases which actually support real relations and which can expose their relations through an API, this is how we find out about those and figure out where your foreign keys are. Mostly those are the big parts of a Django database backend. There are some other things. There's database client. You can run the DB client, DB shell management command. This will just fire up an interactive prompt directly connected to your database. You can type SQL in there. This knows how to do that. Database validation is another class you'll see a lot of times. If we need to do anything special with model definitions to make sure that we can put this model into that database, this is where that validation logic will live. There are also database error and integrity error exceptions, which Django goes out of its way to normalize for you, so that you only have to worry about one exception class, even though every single database has its own internal exception classes. So this is where a lot of times you will see a database error coming out of Django, and what you'll actually see on the message is something like psychopg2.whatever or mysqldb.whatever. This is the pair of classes we use to normalize those so you can catch them easily. Mostly you should not be writing a new backend. Even though, just from what we went over there, you could go look at a database backend and probably figure out how to write one. The only time to do this is when Django doesn't really support either your database or the driver module written in Python that you want to use for it. Maybe if you want to play with connection handling, you can do connection pooling in your database backend. I don't recommend it. I recommend actually getting a pooling connection manager and sticking it between Django and your database. That's a much more robust way to do it. Or if you need really, really, really low-level overriding, like if you need your own custom SQL generation, you can do that at this level. Sorry. I was going to talk a little bit more about that. We are going to get into in just a moment exactly what you would be overriding in your backend. It's going to be what you just saw on that screen, SQL compiler, which is supplied by the backend. But for the most part, just trust Django on this. Like the Oracle guys had to go write their own backend, and they had to go write their own SQL compiler and their own SQL generation because Oracle is weird. I imagine most of you are never going to be in a situation where you have to do that. So, that's database backends. Those are really kind of boring. You're never really going to mess with them, but now at least you know what the components are. Let's start talking about interesting things. Let's talk about SQL compilers. Yeah. Mm-hmm. Yeah. You could do that in a database backend. What you would probably end up doing is a combination of either doing a database backend with a map for the field type you're going to define to the column type you want. There's also an attribute you can set on a model field. I believe it's called getDBType that can return the type of column that field should be represented by. Yeah. Okay. Okay, he basically wanted to know if he wanted to write, say, for Postgres, which has a lot of advanced different column types that aren't necessarily supported by Django, would a database backend be the way to implement that? That he would then be able to have his own Django model field types that correspond to those Postgres column types. And that would be one way to do it. Anything else on backends? Like I said, these are really kind of boring and I want to get past them. So SQL compiler is the next step up the chain. You can see there the module path for it. As the name implies, this takes a Django query object and actually translates it into the SQL that we're going to hand off through the database backend to the actual database driver module. Also knows how to execute your SQL against the correct database, which usually it's going to get from the query object itself or from the query set or from the manager. We'll talk about multi-DB and how that works a little further up the chain. Also is going to give you back your results. Basically, we're going from query through SQL compiler, through database backend, through driver, back to database backend, back to SQL compiler, back to query. So it gets a little complicated, a lot of round tripping involved there. SQL compiler actually comes in a bunch of different flavors. Basic SQL compiler we only use for select queries. That's all it does. We provide other subclasses that know how to handle other types of SQL queries. We have one for insert and one for delete and all that sort of thing. We also have a special aggregate compiler that knows how to do queries that have aggregates in them because those are a little wonky. Anytime you run into a bug where Django isn't processing aggregates correctly, this is probably where that bug is. There's also a date compiler. Anybody know the dates method on a query set? Anybody used that before? That's a kind of a fun one. It's for models that have date fields, and you want to get back a list of all the dates that have models corresponding to them. Like in the admin, you can set an attribute called date hierarchy, which if you go through, like you'll see your list of objects, and then at the very top it'll show you a list of years, and you can click on a year and it'll show you a list of months, and it'll show you a list of days, and you can drill down to objects with those particular dates. Dates query is how we do that. It has its own compiler because it's a little bit weird to do that query. You should not ever need to actually work with or write your own SQL compiler unless you are the Oracle team. They have to do this all the time. Hopefully none of you ever do. Just in case you do, the main thing you care about on a SQL compiler instance is a method called, or on a query instance is a method called getCompiler. This is going to return the SQL compiler that query will use. What this actually ends up doing is calling the compiler method of the database operations class of the database backend, which returns the, not quite the full path. Compiler module is the attribute that specifies the module name. Then query.compiler is going to have the class name. So between those two, you put together the compiler module that you get out of the database operations class and the module name that you get out of the query class. That gives you a full path to a SQL compiler, and getCompiler will actually return you an instance of it. This is what the Oracle backend does. As far as I know, it's the only backend in all of Django that does this, and this may be the reason why this machinery exists, but that's because Oracle has to plug in their own compiler. Next step up is the query class. Query is going to live in DjangoDB models SQL query, not django.db.models.query, which are actually two unfortunately named but completely different modules. Queries are gigantic data structures that are kind of intimidating to look at. Basically, all we're doing in there is lots and lots and lots and lots of bookkeeping. Every time you add filters, every time you add aggregates, every time you add conditions, every time you add extra raw SQL, the query instance gains attributes attached to it that keep track of all of that. Query.py is, I think, one of the longest Python source code files in all of Django. Last time I did this tutorial, it was 1,800 lines of code. Now it's 1,900 lines of code. It grows over time as we add features. Basically, all a query has is these attributes that keep track of, what are we selecting from? What's our where clause look like? What's our order by clause look like? All these things that we need to know to eventually hand off to the SQL compiler to turn into an actual SQL statement that's valid for your database. It does have some methods for manipulating all of this. I don't recommend you ever really play with them, except for one method called addFilter. Basically, every time you do a database query and you do that nice little syntax where you do your lookup type and your thing that you want, title equals whatever, or, date, year equals whatever, what you're doing ultimately is calling query.addFilter. That's the method that takes your lookup type and takes the value you care about and figures out how to patch them into that query so that when we turn it into SQL, we get the correct SQL lookup. Query, again, comes in several flavors. There are subclasses for insert and delete and everything, just like with the compilers. There are specialized subclasses, again, for aggregates and for dates queries. There's also a new class here called raw query. Since this is kind of a new feature, everybody knows about raw, right? This is a method we added exposed on managers and also on query sets, I think in Django 1.3 maybe. Basically, this is a dangerous method, but an extremely powerful method. Raw basically lets you supply your own SQL query. You just write it out there, and as long as it returns columns that correspond to fields on the model you're querying, Django will turn those into model instances for you. So this is basically your shortcut for, I have this incredibly complex query that returns something that looks like this model class, do it for me. We have our own special query class just for doing those because those are ever so fun. You probably don't need to play with query anymore. 1.2 added the SQL compiler infrastructure and all the stuff we've just talked about, which now makes it a lot easier for the database backend writers. Most of it is just going to be your bookkeeping. One thing you might want to know about the string representation of a query instance. Actually, when you ask for that representation, it's going to find out what its compiler is, grab the compiler, compile the query into SQL, and spit that back out. So if you have a query instance that you're playing with, ask for its string representation, and it will actually tell you what SQL it's going to end up executing on your database. Again, I wouldn't really play with it that much. Anybody have any questions before we move into things that actually are worth playing with? Yes, sir. So he's asking, is there something between the raw query interface and using models so that you don't run into like injection attacks and things? Basically, raw is kind of new, and raw basically you are responsible for your own security when you're using raw. There is an older method called extra that lets you stick some parameterized query bits on. Extra actually takes a fragment of SQL and then parameters that get interpolated into it. At least I believe that's how it still works. Extra is a little bit safer, but also can't do as much because extra just takes an existing Django-generated query and tacks this bit onto it. So that's sort of the intermediary. Still doesn't let you do the entire query by yourself. So, yeah. Is there a way to show a query for a save or delete? Not easily without running it. What you could do, let me think about that a second. Can't think of a way off the top of my head to get it. You would probably have to mock up a query instance. Just grab one and like grab a delete query or grab an insert query or grab an update query instance and try to populate it correctly for what you're going to do to see what it looks like. The trouble there would be you would need to know exactly how Django is going to populate that query instance. We'll talk a little bit more about the model lifecycle and some things you can do with that when we get further up the chain actually to models. We're still 3 layers away from ever writing a model class, by the way. So query set. Hopefully everybody has seen a query set. This is actually the thing you interact with that is oh so friendly and handy and does all these wonderful things. A query set basically is a wrapper around a query instance and some higher level methods that manipulate it for you so that you don't have to do all that bookkeeping. Query set is responsible for knowing what database to query and what model to query. It's all your high-level query methods you love. Also, query sets act as a container, and we're going to talk a little bit about this because this is one of the most misunderstood parts of how query sets work. Query set acts sort of as a container for the results that come back from that query, but not always, and you need to be aware of how it does this. So we are going to go into a little bit of detail on how that works. Query sets are lazy. It will not actually grab any results, execute any queries, or do anything at all to your database until it absolutely has to. Basically, a query set is going to sit there with its feet up on the desk until you yell at it, and then finally run off to your database and get some data. The results may be cached, the results may not be cached. A lot of that depends on exactly what methods you call and what you do to it. This is a list. Basically, any method that doesn't return a query set is going to force a query. We'll go over those in a minute. Any method which returns a number of results or checks whether there are results will force a query. I think this is an up-to-date list. I couldn't find any more when I was updating this tutorial. I think this is the up-to-date list of every method on a query set that ends up forcing it to do a fresh query. So I'll leave that up there for a second, let you all get that written down if you want it. Basically, we go out of our way in the way query set is built to keep traffic to your database at a minimum. Whenever we can, it's a trade-off. Whenever we can, we want to avoid having to do new queries and querying over and over and over again because we know what that does to your performance. Basically, only when we absolutely have to. Count, for example, we always run a query because there may have been other updates to your database. You may have new objects. We always want an accurate count. Create and delete obviously have to do this. Exists, we'll talk about in a minute, is kind of a neat method. It takes whatever set of filters you have on your query set and asks if there are any results that match that. Gives you back a Boolean. That always does a query. Get and getter create always do this. Update obviously has to update your database. We'll talk about that one again in a second. Everybody got what they want of this? There will also be, these slides will be online later, and I'll tweet a URL of it. There are other ways you can force a query besides calling one of these methods. If you iterate over a query set that has not yet done its query, so if you use a for loop, or if you ask for an iterator of it, or if you stick it in a generator, Django will evaluate the query and hit your database. If you slice a query set, ask it for one item indexed out of it, ask for a slice of it, Django will do the query right there and give you back whatever slice you asked for out of the query set. If you do Boolean evaluation of a query set, Django will evaluate the query to find out whether it's true or not. With a query set is true if there are any results that it returns. It is false if there are no results that it returns. If you ask for the length of a query set, which you should not ever do, you should call the count method because that's a much, much more effective and efficient query. But if you ever ask for the length of a query set, instead of doing a count query, we will do a query to find out. If you ask for a string, yeah? There are a couple of tricky things in the way query set is implemented. There's a similar thing in that doing exists is faster than doing Boolean evaluation. I forget exactly how len is implemented. I think it's because len... Actually, I don't remember off the top of my head how it's implemented. But you might want to look on the Django track, and I think if you search for the string len in the ticket tracker, there is a ticket somewhere explaining why that is. I can't actually remember off the top of my head. I know why exists and bool are different, and we'll get to that one in a second, actually. Yeah. I don't know that we've ever actually gotten around to implementing it. To me, it's kind of a counterintuitive thing because it's easy enough to just ask for the results in reverse order if that's what you want. I would say if you ever need actual negative indexing, either get your query set and get a list of it and reverse that list, or just reverse the ordering of the query and ask for the first object. So, yeah. Representation of a query set, the repr method, can also force a query because the string representation of a query set is actually the results that it returns, as opposed to the string representation of a query, which is the SQL it will execute. So that is something to be aware of. Anytime you ask for a string representation, that query will evaluate and execute against your database. Anytime you call list on a query set, basically just wrapping it around, you will end up with a list of all the objects in that query set. Anytime you pickle a query set, you will evaluate it and get results back out of it. Anytime you stick a query set in your cache, I believe we will evaluate it and get results out of it. Repr, by the way, deserves a little bit of special mention. We special case the heck out of this. We actually secretly, and you will see this if you ever go back and look at your query log, we stick a limit 21 on the query when we get you a string representation of a query set. Basically, this saves you from yourself. We added this feature to Django after the journal world ran into this. We were testing some kind of tricky code, and we had an error in one of our, I don't even know, I think it was like a template tag or something. But it crashed and tried to show a debug page. And on the debug page, it tried to show us all of the variables that were in the context. One of those variables was a query set. It was a query set that had 1.5 million results in it. And we didn't know this because you would hit this page, and obviously there would be an error, and Django would start generating, a debug page. And then Postgres memory usage would start going up. And then it would start coming down, and Apache memory usage would start going up. And it actually, I think it took us 2 or 3 days to figure out that what was happening was we had a query set with over 1 million objects in it that Django was trying to do a string representation of. So we suggested, as a convenience feature in Django, changing the string representation of a query set to limit the number of objects it will actually show you. And I don't know why 21 was chosen as the magic number, but that is the magic number. When you ask for a string of a query set, you will see the first 21 objects and no more than that. A query set, as we mentioned, is a container. It has results in it after it has done its query. Basically, it has an internal result cache, which I believe is simply called result cache. You can go look at the code on this. It is prefixed with an underscore, which means technically it's a private attribute, and technically you can't rely on it as stable API, but it's been this way at least since like Django 1.1. Iterating over a query set multiple times will only do the query the first time. Every time you iterate over it afterwards, it will just pull the results out of its cache. But here's where we get into the tricky part. Remember I said it acts sort of as a container. So imagine you do this little query. And imagine you ask what the attribute is on the 5th object in that query set. And let's say it's a Boolean and it comes back false. So you say, aha, I'll just assign true to that and save it. Wait a minute. What just happened here? Thought a query set was supposed to be a container. Well, this is why I spent that time going over methods and operations and things that force a reevaluation of a query set. Because indexing is special in a query set. Indexing and slicing simply turn into limit and offset, or whatever your database's equivalent of those are, and will generate a brand new query. Each and every query has its own separate in-memory copy of the model instances it's returning. There's been a very long-running debate, I believe ticket number 17 in Django Track, and we're well over 10,000 tickets now. Ticket number 17 asked for an identity mapper in the Django ORM. I don't know if it's ever going to happen. I don't know if it's worth doing, but be aware Django does not identity map. Every time that query ran in that previous code example, it was getting a brand new in-memory object with no memory of what it used to be and no relation to the other objects you were fetching out, which is why we get that sort of counterintuitive result. So anytime you are indexing a query set like this, my advice is pull that object out into its own little variable where you have it nailed down and know you're working with the same object from one operation to the next. This is, by the way, like 99% of the questions people ask about query sets acting as containers if they run into a variation of this. There are some other interesting methods on query set that a lot of people, and I don't mean to insult you here, when I say that you've never heard of, it may well be that you have heard of all of these. This is just, I talk to a lot of people about Django, I hang out on the users list and IRC channel, and most people are genuinely surprised to learn about some of these tricks. So we're going to go over them because they're extremely useful. One of those methods is update. Basically, this does a SQL update query. It's a bulk update of every record in your query set. So you can do, your query set of, title equals this and date equals this, and then tack on update, status equals live. And it will go through, and for every single one of those, it will do an update, this table set status equals live, where, whatever. Really handy, does it all in one query. One thing to be aware of, if your model has custom save methods, they will not get invoked. Because we are doing this as a single SQL update query. We'll talk a little bit more about when save gets invoked, but generally anytime you're doing a bulk SQL statement, it's not. There is also a delete method that is the same way. Deletes every record in the query set, although it may or may not be a single SQL delete command. This is where we get into the fact that not every database Django supports actually maintains proper referential integrity. When you set up foreign keys, not everything we support, and in particular some table types on MySQL, don't know that you can't just leave an orphaned thing with its foreign key pointing nowhere. So, on those databases and on those engines, Django has to do its own referential integrity managing, which means delete queries can't always be a single delete statement in the SQL, which means these may sometimes end up executing your custom delete methods on your model classes. So that's a tricky distinction to be aware of. As far as I know, it's only if you're using MySQL with MyISAM table type. Might be other cases where we run into that. I think SQLite, we don't run into this. I know Postgres, we don't run into this. There may also be some really scary deletions involving generic relations and things like that that we have to manually delete objects on. So just be aware, you may not be getting a single delete query out of this. You may end up having your delete methods called on your models. You may not. You can't really rely on that either way. There are some tickets going into this if you want to get into the really gory details of why that is. The exists method, which we talked about, basically you take your query set and you tack on exists, returns true if the query has results, returns false otherwise. This is where it gets kind of fun. If the query set is already evaluated, it checks the result cache to see if there were any results in there. If not, it does the fastest possible query we can construct on your database, which in most cases is a select one where whatever, which is often a lot faster than trying to do a select count and figure out whether that's an actual number other than 0. Why isn't this the default Boolean representation of a query set? The answer is that the Boolean representation of a query set invokes the special Python method _non-zero, which is implemented on query sets and has to have its own logic because non-zero is a different question from is this Boolean true. So that's the reason why there are two different methods, and that's the reason why exists is probably the one you want when you want to know if a query set is Boolean true or not. Usually this is a whole lot faster, a whole lot more efficient. Sometimes it won't even do a query, sometimes it will do a very fast query. So if you need to know, are there results in here, do this. It is absolutely fastest when the query set is already evaluated, but still pretty fast even when it isn't. Two methods, defer and only. Has anybody ever actually used these before? These are fun methods. I love these. I think it was Adrian added these. These return partial model instances. So you get back something that looks like an instance of your model, but only some of the fields are filled in. If you asked for fields that haven't been filled in, it will do another query to go get those. Basically, the idea here is to let you control exactly which fields you're going to select. If you know, beyond any possible doubt, that there is only a specific subset of fields that you need, and that querying for only that specific subset of fields will be much faster than querying for everything, use one of these methods. Basically, defer takes the list of fields not to fetch, only takes the list of fields to fetch, which is a little confusing, but sometimes it's better to have the smallest possible list passed in. So we support both ways of doing it. Basically, think of defer as not these fields, only is only these fields. Um, Two other favorite methods of mine, values and values list. These are similar in that they let you control what fields we're selecting, but they don't return model instances. Values returns a list of dictionaries filled in with the values of the fields. Values list returns lists. Values list is actually kind of fun because if you're selecting exactly one attribute off of your model, you can pass an argument which I believe is called flat equals true into values list, and you will simply get a list of all the values for that attribute on every instance of your model in the ordering you specified, which sometimes is really, really handy. Back before we had proper aggregates, this was the fastest possible way to do a sum query, because you could select the numeric value with values list and then do a sum on it in Python. Oh, there it is. Returns the single field name in a single list. You can also write your own query set methods. It's very easy to subclass query set, add your own additional methods to it. Simon Willison, if you want to make a note of that URL, wrote a very nice little article a couple of years back. It actually still all works. We've not changed the API that much since 2008. He showed quite a few tricks you can do to just stick your own useful little methods onto query sets to suit whatever your specific model or your specific use case is. Anybody have questions about query set before we move on? Yes, sir. Yeah. Yeah. Asking if there's a better way to do distinct than to use values list. I don't think we've implemented distinct yet. I'm pretty sure there's a ticket open for it. I would take a quick look at the query set API reference to make sure it's not in there already, because I know if it's not, it needs to be. Okay. I couldn't hear the last bit. I don't think you need the values list. What's the use case? Okay. Okay, yeah, come talk to me later and we'll go over that. Any other query set questions? Yeah. Yeah, asking if it's just list or anything that will iterate over a query set, or anything that tries to turn it into a sequence, putting a query set into a generator expression, putting a query set into an iterator expression, anything of that sort will evaluate it. Okay. So let's move on to managers, and this is where we actually start getting into things you will probably write code with. Like, you can write custom query sets, and some people do, but managers are where you'll probably write your own custom code. They are your starting point for every query. They are attached directly to a model class. A manager has an attribute, self.model, that tells it what model it's attached to, every manager instance in Django. This exposes most of the same methods as query set, so that you can just write your queries simply using the manager. There are some fun things you can do. If you don't specify one at all, Django creates one for you and names it objects. If you do specify one, Django does not create a manager for you and does not call it objects. You get whatever manager you ask for. You can put multiple managers on the same model class. The first one you define, or the first one that Django sticks on there, becomes the default manager for the model. Anything that cares about it is going to get that manager, and it's going to become the attribute underscore default manager on that model class. So a lot of times this is a useful trick to know. We'll see this in action in a little bit when we're talking about generic model work. If you are just handed a model class and you don't know what it is or anything about it, you can grab this attribute to be able to query on it nonetheless. This is how a lot of Django's own internal APIs figure out how to query your models. They just assume whatever you put first is the general purpose manager to use for most queries. How a manager actually works is ultimately almost everything in it delegates to a method called getQuerySet, which returns a query set. Everything else in a manager just calls those methods. So when you do all, when you do filter, when you do get, when you do whatever on a manager, what you're really doing is calling getQuerySet and then calling all or filter or get on the query set object that comes back out of that method. The one exception is raw, which goes and instantiates its very own special query set called a raw query set, which is different because it has to handle the fact that it's just a pure SQL query. So the traditional example for what you can do with these is like, let's say you have your blog entry model and you have this little status field where things can be live or they can be draft. And you want to write a custom manager with a method called live that only returns live entries. Right there's all the code you would need to do that. There's your live method, self.filter, status is live status. Note we're using self.model because we know what model it's attached to. And then you can simply stick that manager onto your entry model, and now you have a method called live. Another thing you can do is put it in query set. This is basically the same sort of thing you'll find in Simon's article. This is a complete example of writing a custom query set class, using it in a custom manager class, attaching it to your model, and taking advantage of the custom query methods you get out of it. This is the sort of thing that can be really handy a lot of times when you have special querying needs on a model. Write a query set, write a manager, stick them together like this. End up with being able to call, in this case, a live method on any query set that comes out of that model. Yep. Yeah. Assuming we did it the same way as in the previous code sample, where we just stuck objects equals one of these managers. Because we're overwriting get query set on the manager. If we then make that the objects manager of the model, we can do this. So, one thing to be careful with, we did override get query set there. This affects every query for that manager, which can lead to some really, really unpleasant results. The worst case is once upon a time on my blog, I thought I was going to get really smart and write myself a little, custom query set and custom manager and custom get query set method that excluded, by default, would only just give me live entries and would exclude any draft entries or anything I'd hidden. And then I discovered that in the admin I couldn't see any of my drafts anymore. Had absolutely no way to get to them because I had deliberately written a model that was incapable of querying for any of my drafts. So this is something to be aware of. That was just kind of a funny thing that I had to go fix. In real life, often those types of examples tend to be much, much worse. So just be really, really careful when you override get query set. One other thing you can do is don't override it, but instead write your own custom methods on the manager and just make sure you always call those methods first. It's a little less convenient, but it's a little bit safer. The real nice thing about managers is you can use them to encapsulate certain types of common query patterns. Like this is one of my favorite examples. Let's say we had a whole bunch of models, and not that I used to work at a large news company where we had lots and lots of different content models with status fields on them. You could write one manager with one method that knows how to query self.model.status equals whatever, and just reuse that manager on every single model class you write, and suddenly you have that query everywhere. Managers are really, really good at this. You can also do more exotic things. Once upon a time, I wrote a library of utilities for the comments module in Django. It's actually obsolete now because a lot of that got added back into contrib comments a couple Django releases ago. But one of the things it added was a custom manager, which knew how to do a most commented query. Didn't matter what model you stuck it on. Didn't really matter which version of comments you were using. It would just give you that method and return you instances of that model in order by the number of comments they had on them. Again, this is a really handy thing you can do. This is the types of uses managers are intended for. Anybody have questions about managers before we take a slight detour into databases? Yeah.
I've seen a couple of Django talks involving where it says get the name together and but custom managers keep coming up, so I'm guessing you guys must think that they're not used as much as they should be.
Custom managers are not, in my experience, used as much as they should be. I use them fairly liberally. At my old job at the Journal World, we used them fairly liberally. At Mozilla, where I work now, there are a few of them sprinkled throughout the code base. I think there may be places where we could use more.
What is the anti-pattern that you're seeing?
A lot of times, it's just putting things into a manager is the traditional sort of programmers are lazy. I hate seeing the same query written twice. I hate seeing somebody who has a bunch of similar models and needs to do a bunch of similar queries on them, writing all of those out by hand, instead of writing one manager class that knows how to do that type of query and stick it on those models. Managers can be a huge time saver. They also can give you a much more natural, high-level querying API than you would from just having to, concatenate together these big queries over and over again. So for me, it's just a, don't repeat yourself, don't write the same code over and over. Write it in a manager once and reuse it. This is my favorite question, using managers versus using class methods. My answer is don't use class methods. Just do not use class methods. So Python has the ability to define class methods, which are sort of, there's actually also something in Python called a static method, but a class method is closer to what a static method is in, say, Java. Class methods in Python are fine. If you really want to use them, I'm not going to yell at you too much. But the thing with managers is they represent these sort of class-wide operations. They represent the query for this class, select instances of this class, delete instances of this class, update instances of this class. And they are separate because we want the ability to have multiple managers on every model, which is why it's not just implemented as class method. If we did it as class methods, we wouldn't be able to, or we'd have to be very, very careful about namespace pollution to avoid having different sets of query methods trample all over each other. So because that pattern already exists in Django, I would say go with that and write things as manager methods. Traditionally, I've written even things that don't interact with the database as manager methods. Basically, anything that would be a class method elsewhere, I end up typically putting in a manager. I almost never write class methods on Django models. And it's mostly just for consistency that I want, since I'm already writing a manager and already using a manager because that's the way the ORM works, I want one place that I can go look and see all the code related to that. I want to see all the class level operations on one page. Does that make sense? Okay. Anything else? Okay. We're almost all the way back up to models. You remember, we started out with a little diagram. We've been through the back end. We've been through the compiler. We've been through the query. We've been through the query set. We've been through the manager. We're almost to the model. We're going to stop and detour off into multiple databases. This is a feature that didn't exist the last time I did this tutorial, and I wasn't quite sure where to stick it, but I think this is the place. Database, basically MultiDB, if you haven't looked at it, uses a system called routers. You have one or more routers in your settings file, and I believe it actually is just called database routers. These determine which databases get read queries, which ones get write queries, which ones get syncDB. Routers can determine on a per database basis whether to allow or disallow creation of relations between models. There we go, the database router setting. The default router that we provide in Django that you're getting if you don't do anything fancy or don't change this at all, basically all it does is I have an object. If it's a brand new object that I just created, save it in the default database. If it's an object that I just queried for, save it back to the database it came from. That's all that the default router does. You can obviously do much more advanced things with them. You can get manual control, you can write master-slave replication. You can write, you can do partitioning and sharding. You can say, any user with ID less than 10,000 goes in that database. Users with ID over 10,000 go in that database. The documentation is pretty good on how to write a router, and we'll get into a little bit more detail on that. But first, let's talk a little bit about how to use them, because there are some special methods that got tacked onto things with the addition of routers in, I think, 1.2. Query sets grew a new method called using. This takes the name of a database connection and passes it all the way down. Query set will pass it into the query. Query will make sure that it loads the correct database backend and SQL compiler for that database that it's using, and we will hand off to the correct database driver and finally the correct database. Manager has a method called dbmanager, which you can call, pass in the name of a database connection. You will get back a manager instance that uses that database connection for all its queries. Save and delete on models also take an argument called using, which is the name of a database connection. They will make sure that you either save that model into that database or delete it from that database. Sometimes those are handy. What this did under the hood was add a new attribute on every model called state with an underscore in front of it to show that it's private and secret, undocumented, unpublic API. All this is really is an instance of a class called model state, which has an attribute called db, which is the name of the db connection. All we do is set this automatically anytime we call save. We set the state of that model to whatever database we saved it into. Anytime a query set does retrieval of a model, it sets state to the database that it came out of. Maybe it's a little overkill for state to be its own class, but we might need to add more information to it later, so that's the way we went with it. The use case on these are what we talked about, sharding. You can write a router that says, these write queries go here, these write queries go here, these read queries go here, these read queries go here, and maintain, partitioning, sharding, whatever you want of your database. You can do your replication. You can do all writes go to the master, all reads go to the slaves. You can do this natively in Django. You couldn't do this very easily up until about a year, I guess about 2 years ago. You can look around and find lots of really scary, complex solutions people came up with for doing this type of replication in Django. You can do different types of data sets. You can even override getQuerySet, since QuerySet takes a using method to make sure that a manager always uses a particular database. So you can say, this model always comes out of this database. Yeah. Okay, so asking whether people typically actually use routers for this or use their database's own replication facilities, I'd say the answer is a toss-up. Part of the problem is that some of the databases we support have historically had very poor or very flaky replication tools available for them. So having support for it in the framework is handy for when you're stuck in one of those situations. Personally, I would prefer, much as I prefer to use a database's own connection pooling, like I'd rather use pgpool or pgbouncer than write my own backend that does connection pooling, I would rather use a real replication tool developed for the database. But it's nice to know that you have the option in Django, and sometimes that's your only option because sometimes the replication tools just aren't there. Personally, I would be more inclined to use routers to do sharding and partitioning. For me, that's the big win. Limitations on MultiDB, there are still some things it can't do. Most databases themselves do not support relations between databases. Some do. I think Postgres does now. Oracle might, but I doubt it. I think I remember reading that. Most databases don't support this, so this is not something really necessarily that we're going to allow. The order in which you specify your routers in your settings is important. Basically, we run down that list of routers in the order it appears in your settings, and the first one that looks at a query and says, oh yes, use this database. So the first one that returns the actual name of a database to query is going to win. So if you have sharding router number 1 and sharding router number 2, and sharding router number 1 returns a database name, sharding router number 2 is never even going to get asked. So be aware of that, and be careful in how you write your routers if you're going to be using multiple routers to do these sorts of tricks. Any other questions about routers before we move on? Okay, so we've talked about a lot. We've talked about all these little things, and finally we are back home. We are at models. We are at the high-level Django interface for representing your data. One model class, most of the time, you can do some tricky things with it, represents one database table. One field in a model usually maps to one column in that database table. Give you all sorts of options on there. Save and delete your data. Custom methods stuck on them. Do all your business logic. This is what everybody learns how to do in the Django tutorial. We're finally back to that point, and we're only, how far into this tutorial now? Almost an hour. Model classes are kind of fun. They use a meta class called model base. Before I go further on this, because this is an important topic, raise your hand if you genuinely understand what a meta class is and how it works. Okay. So, everybody understands the idea that in Python you can define a class, and you can create an instance of that class. You have a constructor method on your class that tells how to construct an instance. A meta class is a blueprint that tells Python how to construct entire class objects. Lets you do lots of really cool things, reach in and override Python's own class building machinery. We use them all over the place in Django. We use them in some places we probably shouldn't use them. Models have to do this. Model base is the meta class for all Django models. It sets up some attributes on the model class. It delegates some of the others. Basically, when you declare your little inner class meta, it reads through what's in there and creates an instance of a class called options, which it then attaches back to your model class so that we have access to that. Basically, meta is just syntactic sugar to make it look nice and be easy to write. What it ends up as is this options class. Also sticks on some per model exception classes, things like the does not exist exception, which we write one of those for every single model class. Send some signals through the Django dispatcher saying, hey, we're preparing a class and we're registering a class. Does offer some customization hooks. There's a method called contribute to class. Anytime you add an attribute to a class, and it's like, say, you put a model field in your model. Every model field class has a method called contribute to class. The meta class ensures that that method gets called and lets that model field add any special attributes or methods onto the model. Like anytime you add a date field, you automatically get a get next by this type of date, get previous by this type of date. Those methods get automatically put onto your model by the contribute to class of date field, which is called by the meta class. So that's a useful thing to do if you want to write something that you're going to stick in a model. You can do contribute to class and basically get the ability to rewrite parts of that model as it's being constructed. There's also a signal called class prepared. Everybody knows about signals, right? Anybody not know what a signal is? Okay. Django has a dispatcher. It's not asynchronous, even though it looks kind of like it is. Basically lets you send signals with particular names and listen for those signals and trigger code to run when those signals are sent. There is a signal called class prepared, which is fired off by the meta class as soon as it finishes building the model class. Class prepared is your absolute last chance to go tweak something on that model class before it gets finalized. Contribute to class gets past the model class that it's being attached to and the attribute name on the model class, which is sometimes important. Otherwise, like I just said, you can stick that on anything you want to put into a model. Basically, it doesn't matter what type of object it is. If it has a contribute to class method, we will find it and we will call it for you. Mostly this adds special query methods based on model types. Class prepared signal has only one argument, if you want to listen to that. That argument is sender, which is the class that we just prepared. Django actually uses this. This is the method that makes sure you have a manager. We run through the entire meta class. We run through all the contribute to class methods. We've finished building the class. Then we send this signal, and Django says, hey, do you have a manager yet? If you don't have a manager by that point, that's when we create one, call it objects, and stick it on your model. The options class, which is just your meta declaration, lives in DjangoDB models options. This is all of that stuff, plus a little bit more metadata about the model. This is one of the most insanely useful classes that is not covered anywhere in the Django documentation. Ends up as an attribute called _meta. Again, this is private API. It's undocumented. It's technically unstable. It hasn't changed since like Django 0.96 though. Things you can do. Meta.fields is a list of all the fields on your model. Meta.many-to-many is a list of all your many-to-many relations. GetField can return the actual field objects that you can then introspect. So let's say we have our entry model that we wrote a while back. We can get its options. We can look at, well, what's the list of fields on it? There they are. This is how things like the admin and model forms find out what fields your model have. We can ask for its title field. And there it is. It's a char field instance. We can ask for things like the max length of the title field. So we can introspect and find out validation constraints this way. And again, this is how some of Django's form system does it. Another tricky thing you can do, you can grab, say, the user model, get a user instance, get another one, grab the meta instance, grab the username field. You can get the value of that field without necessarily even knowing its name. So this is obviously a really simple example. There are some fairly powerful things you can do with this. I've written a lot of model introspection code in my time. I've written code that looks for specific types of fields and knows what types of queries it can do on a model. We talked about things like, say, that example with the status field, where we could write a bunch of models that all have a status field. I've written code that rather than sticking a manager on every model with a status field on it, instead the code introspects the model to see if it has that field and does the query for you. All sorts of really cool things you can do with that. Any questions before we move on to lifecycle? Because this is one of the fun parts, and this is something we're going to talk about a bit. Instantiating a model obviously calls the _init method. That's your constructor, every Python class. Where we differ from a normal Python class is as we start, we send a signal called pre-init, which you can look for, which means you can know every single time Django is instantiating an instance of a model. Field values get initialized if we have them. If we're creating a new object with values, we use the values you passed. If we're creating an object from the database, we use the values from the database. Otherwise, it's just blank, and we assume we're creating a new object. Then we send the post-init signal. By this point, if the model instance has data in it, it will be in there, and you can listen for it. Saving data in a model, call the save method, which actually, and I've mistyped that, calls a method called saveBase. SaveBase is where we figure out if we're doing an insert or an update query in the database. It's where we figure out what database we're using, and it saves the data. There is a reason why these are two different methods. If you go look through what save does and what SaveBase does, it's because of API cleanliness. Basically, this means you can easily override save and call up to the superclass save and not worry too much about having to do all this logic or trampling over something that absolutely needs to happen to make Django work. That's why those are two separate methods. Deleting a model calls the delete method, figures out what related objects we need to delete, even on databases that don't support it, and the logic for that is kind of scary. So if you ever want to have nightmares, you can go look at how we figure that out. There are some points to customize this. You can override save or delete. You can listen for the signals we send. Overriding save, this is something that happens fairly commonly. There's even examples of this in the Django documentation. But just a note on how to do this correctly. Doing just the argument self is wrong. Used to be there were attributes force insert and force update, which did pretty much what they sound like, which used to work on 1.1. 1.2 we added the using argument for multi-database. So what we recommend everybody do now when you're writing one of these save methods or a delete method is everybody understand this little asterisk syntax? Basically, you're saying this method accepts any combination of arguments you want to throw into it and pass it along up to the base model save. Otherwise, don't really worry too much about setting these up. Overriding delete is the same way. You should probably always do that because delete now takes arguments that it didn't used to take. Although overriding delete is a little trickier, you can actually skip calling the parent class delete if you want to, which means you will never actually delete anything from your database by calling delete. I think there's an article, it's 4 or 5 years old, so it's out of date, but this is why I mention it. There's a guy who wrote a whole system of a custom manager which knew how to hide objects that had a deleted field set to true, and then a custom delete method which wouldn't actually delete them from the database, it would just set that value to true. And then that gave him a delete with undo, so that he could trust his possibly untrustworthy client to be able to go into the admin and have full access to delete things. And then when the client called screaming at 2 o'clock in the morning, OMG, I deleted my whole site, he could just turn around and go look up the objects in the manager and set deleted equals false, and everything magically came back. This is a really handy pattern, something I recommend you look into. Do not override init on a model, ever, for any reason, please. This is a very scary method that has to do what it does in a specific order in order to make sure your models work. Don't mess with it. If you want to mess with init, listen for the signals. The full list of lifecycle signals are, these are in django.db.models.signals. Pre-init and post-init are sent at the beginning and end of constructing a model instance. Pre-save and post-save are sent at the beginning and end of save base. Pre-delete and post-delete are sent at the beginning and end of the delete method. Using these signals, you can actually figure out basically everything that happens to a model instance over its entire lifetime and reach in and mess with it if you want to. My first draft of comment moderation actually specifically listened for the pre-save signal coming out of a comment object as a way of knowing that a comment had been posted without having to monkey patch anything else in Django. So those are the types of useful things you can do with these. Model cache is also kind of a cool thing. This lives in django.db.models.loading, but now you should actually import it from db.models. I believe this is now actually, we haven't officially promised that it's stable API, but it's been there for so long that we finally put this import in that you can probably rely on it at least for the next couple Django versions. This knows about all the models you have installed. Also does some tricky things. Back in the very old days, we could sometimes get duplicate instances of a model class because you could import the same model from different locations. Like you could do from this app.models import, and then you could do from my project.thisapp.models import. And you could actually end up with 2 copies of the same model class, which was kind of scary because it meant we would set up all the relationships twice and populate some attributes twice and could actually break things. So this is the real reason why we have this, is to avoid running into that problem. But it also, as a side effect, provides a very generic way to get at and query models. We track every model you have installed by its application label, which is just the name of the app it lives in, and its name. So for example, the user model has a label of auth and a name of user. These exist on the options instance as app label and module name. Module name harkens back to, if anybody remembers pre-magic removal Django, back when a model was a module. But here's just a simple example of what the model cache does. You do get model and pass in an app label and a name, and you get, in this case, the auth user model. You can go ask for the app auth. You can ask for all the models in the auth app and get a list of them. You can do a lot more stuff from this. I've written generic querying frameworks that take an app label and a model name, go grab that model, potentially grab other models from that app, grab their default managers, return them to you so you can query, introspect their fields, tell you what types of fields they have. You can write really fun and sometimes really life-saving code if you know about this. Useful methods there are getModel, which returns you a model class. GetApp returns the actual models module of that application. And getModels, given the app, returns a list of all the model classes in that app. There's also getModels, which returns, without an app, every single model you have installed based on your installed app setting. This lets you do some generic querying. You remember we had this default manager attribute. So you can just go specify, and this is actually literally how some things in Django work. Things like the auth profile module setting is an applabel.modelName string, and this is almost exactly how it goes and finds out what user profile corresponds to a given user account. You can write very generic, I don't have to know anything at all about this model or what it is or what fields it has type of querying using this. And it is really everywhere. Auth profile module uses it. The content types app, which we'll talk about in a minute, uses app label and model name to track models. The admin uses them to identify models in URLs. It just goes on and on and on. This machinery is used everywhere internally. Yeah. If you have a circular import issue, this may not solve it. This will end up importing whatever is necessary, but importing it at Django startup, because we only, basically when Django is first loaded, we're going to run through every models module we can find in every one of your applications and register all those model classes in the model cache. So we're still going to be pulling them out of there. We're still going to have to import all of those at least once and import anything that they import. So it may not actually solve your problem, but at the same time, it isn't an import statement. So it's one thing you can do. Model fields. Everybody probably has written a model. Everybody probably has stuck a bunch of, char field, integer field, foreign key, many-to-many field, all these things on a model. Most of them live in DjangoDB models. Some bundled contrib apps include more field types. Some third-party applications include more field types. Basically, all a model field is a particular type of data and some constraints on values of that type. Every model field has a getInternalType method, which can return the name of a built-in field type. Basically, if you write something, say, that ultimately is character data, you can return charfield as your internal type. And Django will know to treat this the same way it treats its own character fields. DB type can name a custom data type to use at the database level. Every model field has a method called toPython, converts a value from your database into the correct Python type. A method called getPrepValue, which converts the Python field value back to a generic database-ish format. And then another method called getDBPrepValue, which applies any specific quirks for the database we're going to save it into. Querying, pretty much the same thing. There's a method that converts you back to the correct format for the type of query you're doing. And again, there's a separate method called getDBPrepLookup that's going to apply any database-specific quirks that we need to know to get this value out of your database. Saving is the same thing. There's a method called presave on every field that does generic preprocessing. then a DB prep save that allows you to do any specific formatting for your database. It's a method called form field on every model field. This returns, well, can return an appropriate form field class for representing that model field type. That's how model fields work, or model forms work. There's a method called value to string, which converts that field's value into a string for the serialization system. You can also write your own fields. From scratch, you can subclass models.field, use the subfield base metaclass, and overwrite what you want. There's actually a really good tutorial in the Django documentation for writing your own custom model fields. I recommend you go take a look at that if you've ever felt a need to. There's the link. Basically, just how to custom model fields is all you need to know. Other things you can do, and this is more common and more useful, is you can just subclass an existing model field type. You can override methods there or don't override methods. The reason I mention this is, here's a simple thing. Let's just write a subclass of date field and call it pubDate field. Then we can write a method called getPublicationDate, where all we do is look at a model and find out if it has a field of this type and gets the value out of it. When I used to work at a newspaper where we had lots and lots and lots of different models which all had publication dates on them, this is how we did it. We could just generically ask, hey, what's the publication date of this object? Didn't need to know what type of object it was, didn't need to know what the field was named on the model. We could just go look for that type of field and yank it out. This is really fun stuff to do. Model validation was a new thing we added a while back. And I mention this under fields because it starts at the field level. Basically comes in three types. There's field level model validation, instance level model validation, and uniqueness level model validation. Every model instance gets a method called full clean, which can run this for you. This ends up calling clean fields. Each one of the model fields defines a method called clean. This is the same as on forms, as we'll see a little bit later on. There is additional validation you can stick onto a field this way by writing a clean method. This is basically your instance level validation. Clean on the model is called after clean fields. So basically, once we've looked at every field and every field says I have a valid value in me, then we ask, is the model as a whole valid? You can perform validation with multiple fields simultaneously this way. So you can have particular combinations of fields that have to have specific values. Then there's validate unique. This is going to look at all of the unique constraints you've declared on your model, your unique declarations, your unique for a date declaration, your unique together declarations. Make sure that they're all correct. This is the last step in the model validation chain. There is a full clean method as well. Basically, this is everything being run at once. Ends up raising Django core exceptions validation error if you have an invalid model instance. This is the way to do it. You do have to call this manually. Saving a model does not implicitly full clean the model. So if you have a model instance you want to save and you do have validation logic on it, and you want to know it's valid before you try to save it and potentially get an exception, call the model instance's full clean method. And that will let you know going in if it's as safe as our validation system can verify for you. Kind of a whirlwind tour there. Model validation is still kind of new, and we're going to talk a lot more about validation in general when we get to forms. Does anybody have anything specific they want to know about that? I can go back over it, or we can move on a little bit. Going once, going, yep. Full clean, okay. So you want to clean just one field on the model, is the question. Full clean will do that for you. You can also grab that particular model field by using the options instance, as we showed a little while back. You can grab that field out of it and call its individual clean method. Personally, anytime I'm worried whether a model instance is valid, I just clean the whole thing, because there might be other errors that I haven't realized I have yet. So, and you will get a list of validation errors out of it. We'll talk more about validation and how that works when we get to forms, and we will also talk about when to use forms to validate things and when to use models to validate things, which is ever such a fun topic. Model inheritance. This was something we supported for a while, then didn't support for a really long time, and now we support again. Comes in several flavors. You can get abstract inheritance or concrete inheritance. You can get database level or non-database level. You can get Python level or not Python level. So abstract models, basically you declare abstract equals true on your model class. Does not ever create a database table for that model. Subclasses of it, if they are not abstract, will generate a table with both their own fields and any fields they inherited from the abstract model. Subclasses of an abstract model can also subclass and override the meta declarations of the parent. There are some restrictions. You cannot declare DB table or any other type of database specific declarations in meta because we're not going to create a table. Because you can end up inheriting a foreign key into multiple types of models, there is a special syntax for the related name value. Related name says what attribute we're going to stick on the model to access that relation. We don't want a name collision there. There's basically an interpolation syntax. This is covered in the documentation if you want to look it up. Use case for abstract models is basically any time you have a common set of fields that have to appear in every model you're going to set up, or most of the models you're going to set up. Write those fields once and then just start subclassing from your abstract model. Also, if you have a bunch of common methods, but not necessarily fields, you can make sure that every model inherits those. You can also do meta declarations because abstract classes inherit their meta declarations. Do you have a question? What do you mean by being an anti-pattern for a normalized database? Yeah. Okay. Okay. So the question there is how to, basically, is this an anti-pattern for normalization? Sometimes it is, sometimes it isn't. Like, for example, a lot of times I would prefer to have a model representing, say, a reporter and a foreign key back to that. Publication dates, author may have been a bad idea. Titles, publication dates, that sort of thing, generally are not worth doing their own database table for, but at the same time show up so often that it's not really a normalization problem to be redoing them in every model. It's just a very tedious code writing problem to be doing them in every model. So personally, I probably wouldn't do a database table just for titles, for example. You could if you really wanted to, but I wouldn't. Again, you can also get common custom managers. Basically, anytime you have something that you want a bunch of models to inherit and that's not too complex, an abstract model can be a way to do it. We also support database level inheritance. This is what we call concrete inheritance. There is really not a special mechanism here. You just subclass the model you want to inherit from. You cannot directly subclass meta. In this case, you can override things by supplying your own declarations there. You can add new managers, and you will not be inheriting any managers from the parent model class. Under the hood, this is always implemented as multi-table inheritance. We do not do single-table inheritance in Django. The subclass ends up creating a table with an implicit one-to-one relation back to its parent. Basically, this is the you can specify a one-to-one field, and you can set parent link if you manually want to set this up. But basically, this is just the same as two tables with a foreign key that's unique on both ends. Parent-child relation, you can traverse that the same as any other one-to-one relation in Django. Use cases for this are, the classic example is a restaurant is a place. So a restaurant inherits from place. And at the database level, this does the right thing because all it does is set up a restaurant table with a relationship back to the place table. But personally, I don't think database level inheritance is a great plan. There's a really, really good article that says this is a quagmire. In fact, he compares it specifically to the Vietnam War. Says that inheritance in object-oriented languages and relations in a SQL-based database just don't match up. They're not concepts that work together. But it's there. There's also a Python-level inheritance. You can create what's called a proxy subclass. Set proxy equals true. Your proxy class will use the database table of its parent, can add or override things in meta, can add new managers, will inherit the parent's manager, must have exactly one concrete parent, can have any number of abstract parents, but the abstract parents cannot define fields. That's the restrictions on that. Proxy models are really handy when you have, say, an existing model in some app that you didn't write and you want to add functionality to it. Write your own app that subclasses it as a proxy and start doing that. You can add managers, add add meta behavior. This gets around the need to monkey patch someone else's code a lot of times. So this is actually the one big use of inheritance that I would recommend in a lot of cases, because so many times you end up with someone else's code that's not quite what you want, but so close. And in a lot of those cases, just doing a proxy model subclass does it for you. Some general things to know about inheritance. Querying a model will always return instances of that model. You will never get instances of the parent model. You will never get instances of any child models. You have to explicitly traverse those relationships yourself. Subclasses can never, under any circumstances, override field definitions in their parents. This is a really important thing, even with abstract models where we wouldn't necessarily be creating something. This basically makes the Liskov substitution principle work in Django, for those of you who did the computer science background. You should always have the same set of fields on a subclass as you have on the parent class, at least. You can add fields, you just can't replace or delete them. Abstract classes, if you happen to somehow get access to one of them and have a manager on it, you cannot actually query it. Doing any of these things will raise an exception. The other thing is if you are doing multiple inheritance for some reason, and God help you if you are, the first parent class to define a name will win. This may be a case where you want to look into Python's method resolution order, which is ever so much fun. When in doubt, my advice, don't use inheritance. Basically, the only times I would use it are sometimes abstract inheritance, if I've got a bunch of models that have behavior in common that I want them to inherit. Sometimes I will use a proxy model instead of having to monkey patch someone's code. But again, those situations are fairly rare. I highly recommend you just forget that inheritance exists in the ORM. And sometimes I wish I could too. Yeah. Yeah. Well, in terms of pattern, like the question there is, what type of an object is a Django model instance? Is it a domain object? Is it a database record? What is it? Pattern-wise, Django's ORM is kind of halfway between active record and data mapper. The manager layer and some of the other things are kind of data mapper-ish, and we do mix some business logic into model instances. For the most part, though, we are an active record style ORM and expecting basically Django model instances to be that sort of all-singing, all-dancing, complex business logic object is a bad idea, which is another reason why inheritance is normally not the thing to be doing with them. What plays well with South, I don't know, because I've never actually used any of our concrete inheritance features with South. In fact, I've never used inheritance with South at all. So that would be a question possibly to ask Andrew Godwin, because he would know. Yeah. Okay, so inheriting from users. This was 99% of why people wanted us to bring back inheritance. It is absolutely the wrong way to add things to user. The auth module supports setting up your own custom profile model that adds additional information that your site cares about for users. It specifies a way that you can put it in your settings so that Django knows what it is, so that you can easily retrieve it. I've written applications that let you easily manage that information. My recommendation is go type auth_profile_module into Google and read what that says and use that instead of ever doing inheritance. That's what that's there for. Yeah. Yeah. That's the mechanism for adding more information about a user. That's what it's for. I would never recommend subclassing. Yeah. So basically, basically subclassing some code that adds an audit trail every time it gets saved or whatever. Yeah, that would be something you could do with it. There are also some hacks that you can do that don't involve inheritance. I'm not sure what I would prefer there. I would have to actually look at the implementations. So, almost done with the ORM now. Some miscellaneous stuff. You can set an unmanaged model. Set the attribute managed equals false in meta. Django will not attempt to create a DB table. Django will not attempt to maintain a DB table. Hopefully South, I think, will ignore that model and not try to migrate it. Django will not add an automatic primary key field to it. Basically anything Django does database related, it will not do for this. Will not attempt to create many-to-many join tables. Will not attempt to create or maintain foreign keys. Basically, the whole idea here is you either have an existing table or you have a database level view or some sort of stored procedure that you can query, and you can set up a model that looks like it, but you don't want Django trying to actually create a table for it or manage that table. This is a useful thing that I've used more than once with Postgres views. Generic relations live in content types, contrib app in generic. Requires content types to be installed, allows you to basically do a foreign key that doesn't specify what model it relates to, and can relate to any instance of any model you have installed. Quickly, how it works is you set up a foreign key from your model to content type, and a field that can hold a generic primary key value, and then add a generic foreign key, which you can import out of content types, specifying those two fields as arguments. So basically looks something like this. The real use case for this is tagging. I think Django tagging originally did this. Now Django tagging is a little more complicated. Tagit is another tagging app that is even more complicated, but still I think does some generic descriptor stuff. This is really handy. It's also really, really inefficient and really, really overused. Personally, I almost never use generic foreign keys. But like inheritance, there's something that a lot of people seem to like. Content type is basically just a model that stores an app label and module name. Does primary key lookups against that model. Generic foreign key basically only works for accessing it directly. You can't pass it into filter, you can't query on it, because you can't express it easily at the SQL level. There is a reverse generic relation that you can declare on a class you intend to point to. It's just the class generic relation, and gives you a reverse relationship back to the thing with the generic foreign key. Q expressions. Who has used a Q expression? Okay, a lot of you. This is django.db.models.q, basically just your field lookup syntax. Anywhere that you can specify field lookups, you can specify these. You just have to specify them as positional arguments. The nice thing about them is they combine using logical operators, which lets you very easily build more complex queries from fragments of lookups. You can also negate them with a logical not, which is nice because otherwise you can't actually negate a query in Django. You have to do exclude instead of whatever you were doing. They do allow you to reuse query fragments over and over again and write them only once, which is really, really handy. The other special expression type is F expressions. Who's used one of these? These are my favorites. I love F expressions. This is django.db.models.f. All it does is takes a field name and becomes a reference to a field name. It is usable as a lookup value in a query, and this is how you write self-referential or field-comparing queries in Django. If you have, say, a model that has two numeric fields on it, we'll call them A and B, you want to know how many instances have A as a lower value than B, you can basically stuff B into an F expression and be able to write that query. This lets you refer to a model field when you're writing an ORM query. Really handy thing. There is the extra method, which we talked about earlier. Lets you stick a little bit of raw SQL in the query. Lets you return some extra attributes on the instances you get back. It's only occasionally useful, not all the time. Natural keys. Anybody read the Django Advent article on natural keys? Okay. Natural keys are really handy. Let you define a method called natural key, which should return some sort of iterable type, traditionally a tuple. Content type's natural key is a two-tuple of app label and model name. These are kind of handy because the serializers will use your natural key if you define it. Content type and permission both do these. Have custom managers that can do lookups by natural key. How did I end up back a slide? Here's an example. The permission model in Django. You could write permission.objects.get and specify, the full set of arguments. Also specifies a method called getByNaturalKey, which just takes these three values which uniquely define it. For those of you who are used to working with composite primary keys, this is as close as we can get in Django right now. We still do not really support composite keys, but we're working on it. This is sort of a stopgap. It's also kind of useful if you define a natural key method and a manager with a getByNaturalKey method. The whole serialization system will work. You can import and serialize and deserialize objects at will this way. Really kind of handy. I like it. Most of the time, if I have something that would sort of naturally have a composite primary key, I'll do this for it. That's basically everything I have on the ORM. We are, roughly an hour and a half, a little more than that, into the tutorial. Does anybody have questions about the ORM in general? Anything we've gone over? Yeah. Yeah. Underneath a query set object and a query sometimes, if you go look at them, basically it's the same code, it's two different interfaces to it, which is why some of the logical operations work on query sets as well as on queue objects. Yeah. Yeah.
Do you have a recommendation on how to store binary data in a database?
I wish we had a real binary field, and I wish every database supported it, would be my recommendation. If you want to store binary data, I feel like you're probably stuck writing your own custom model field for it. It's sad that that's the case. You might look in track. I've looked once or twice into it as part of wanting to add bitwise lookups to the ORM because I really want bitwise lookup types. It gets kind of scary, especially on Oracle, which is the reason why I haven't actually written that code yet. Anything else on any part of the ORM? Yeah.
Well, I have a question that's more related to Django and transactions. I'm not sure if you want to take that.
Okay. I'm not an expert on transactions, but I'll do what I can.
Okay,
If it has to do with transactions, my recommendation would be look at the API of a Django database backend and look at the methods that are defined in there. If you don't see something obvious that does what you need, it probably doesn't belong in Django. Like, it probably would be something you would have to do external to Django or do at a different level. All of the transaction handling stuff ultimately ends up in the database backend module. Like, that's where everything in Django that knows how to do those is. Okay. So everybody now feel like they've had their brain, pounded into mush by all this boring reciting of how the ORM works. But now at least you have an idea of all of these components and how they work together. Because now we can answer a question that we began with, is all the way back there when we type, entry.objects.all and get back that query set. Now does everybody at least have sort of a high-level conceptual understanding of everything that goes into that? Of, okay, entry is a model class, .objects is a manager, .all is a query set query method. We're going to go, query set is going to wrap a query. It's going to introspect the model to get the list of fields on the model to know what columns to query out of the database. Query is going to put together all those parts. SQL compiler is going to translate those parts into a SQL query, which is going to hand off to the database backend, which is going to get the cursor, which is going to finally send it off to the database. The data is going to come back through the backend, is going to come back to the query, is going to come back to the query set, which is going to cache it in its internal results and give you instances of that model, which when they are created are going to send pre-init and post-init signals. Basically everything we've talked about the past hour and a half. All of those things are happening every single time you write a query as simple as get me all the entries in my weblog. With that, I think we're about halfway through and maybe we should take our break. If anybody has specific questions for me, I'm going to go get some water, but I'll be happy to listen to them. Okay. I believe we're back in 20 minutes. It's 3:07 right now. Be back, 3:30-ish. Okay. A little bit faster because the things we're talking about now are not nearly as complex as the ORM. We're going to start with the forms library, which is really kind of fun, and if you've understood even about a quarter of what we did on the ORM, the forms library will seem positively simple and friendly and fluffy and happy and rainbows by comparison. In fact, most parts of Django do after you've looked at the ORM. So major parts of the forms library. You've probably already seen a lot of these. Forms, fields, widgets, some form generation utilities like model form, and the media support. We're just going to go through these. We'll talk about media support kind of last. We'll start with widgets. That's sort of the bottom up. Widgets in the form system are your low-level display, your low-level parse data out of a submission. They know how to render the HTML for a particular type of control. They know how to pull the data out. So when you send, your request post data in there, the widget is what knows how to figure out this piece of data in request.post is that field. Widgets, basically we supply one widget for each type of HTML form control. We may end up adding more of these for HTML5 down the road. Hopefully once we know exactly what the HTML5 form controls look like. So there is a widget for a text area. There is a widget for a password input. This is why there's not specific field types for this, because in theory any text-based field type could be a text area, could be a password input. You basically use the widget to dictate that. Widgets can also bundle arbitrary media, so they can throw in their own CSS, their own JavaScript to include and use actually when they're being displayed on a page. Important methods on a widget are render, which pretty much does what it sounds like it would do. Render is responsible for outputting the widget as HTML, as a Unicode string, for what actually needs to end up in the web page. Takes a dictionary of HTML attributes as an argument so that you know how to render it and what HTML attributes to put in. One tricky thing is that it gets a value. Value is not guaranteed to be valid. Writing a widget on the assumption that the value is valid is a bad idea because you will be getting values into your widgets that either have been found to be invalid or have not yet been validated. Sometimes you'll get some that have been valid, but there's no guarantee. There's a value from data dict method. This is basically if you take, say, request.post and pass it in here, this is how the widget knows what data to pull out of request.post that says, hey, this is me. So if you have, say, an email field, this is what would go find the actual email address and return it for you. Data and files are the attributes there. Hopefully everybody's familiar with request.post, request.get, request.files. That's what's going into this method. Finally, ID for label. This is what's going to get you the HTML ID of the widget in the web page that ties it back to an HTML label element. There's also a build attributes. This lets you, because there are ways to provide other attributes to a widget besides just whatever is natural for it or defined on its class. This combines everything and gets you the final set. It is useful to know about this if you want to, say, override render. You probably want to grab this and get that full list of attributes. There is a special case of widget to talk about, which is called multi-widget. This is the sort of special purpose. It allows you to take two or more widgets and combine them into one. The example of this, and we're going to see this over and over again, is sometimes we need to accept a date and a time and combine them into one value on the back end. These are two widgets which become one logical value. So we have a split date time widget that basically wraps around a date widget and a time widget and knows how to combine them. Multi-widget, the value argument to its render method is a list of values. It needs one value per wrapped widget. Or you can give it a single value and a method called decompress will be called on that value to unpack it. So say with a datetime widget, you could pass a single datetime instance in there. The decompress method of the datetime multi-widget knows how to split that into the date part and the time part. That's basically the example. Widgets, there's not much else to say about them beyond that. They're not really that exciting. You can write your own, you can tinker with the ones Django provides, and there's a whole list of them in the documentation. The only other really interesting thing about them is the media support, but we're going to get to that separately later on because media support is really cool, and we will talk about that as its own topic. Next step up from widgets is fields. Each form field type represents a data type and some validation. Each form field is typically associated with one default widget. Fields are where we start performing validation and start returning values in the appropriate Python types that we care about. Any field can be arbitrarily specialized or arbitrarily generic. Do you have a question? Okay. Field validation, basically there's a method called clean. It implements a three-step process, kind of like what we saw in model validation. The first step here is we convert the value to an appropriate Python type. Then we run the field's own validation method. Then we run any validators that are attached to the field. We will end up raising django.core.exceptions.validation error. In older versions of Django, you would see mention of something called django.forms.validation error. That still exists, but it's an alias back to this, so that we have a single unified validation error that's raised by both models and forms. Converting a field value is a method called toPython. Basically, this takes the value, converts it back to the appropriate Python type, spits it back. If for some reason you can't convert that to the correct type, raise a validation error. Field level validation is the validate method. It gets the value that has already been converted, so we only get here if we've actually been able to convert it. If the value is valid, this method does nothing. If the value is not valid, it raises a validation error. This is a pretty common pattern we're going to see. Validators are new-ish as of, I think, Django 1.2. think they were already there for 1.3, so I think they were 1.2. These are additional validation constraints. You can basically throw any number of them in. They're really, really cool. And all the validators you attach to a form field will be run during validation of that field. A validator basically is just a callable. It takes a single argument, which we call value, raises a validation error if that value is invalid. There's a whole list of built-in ones in Django.core.validators. They are there because they are not just for forms. You can slap validators on models if you want to. At least I believe you still can. That was the original purpose of them being in core. So you can stick a validator on a model. Here's an example. Very simple validator. This requires that you have the string pony somewhere in the value you are validating. You can stick it in a model field. You can stick it in a form field. In this case, a model form generated from this model would require a pony in that field, which is ever so handy. Has a method on a field called runValidators. Basically iterates over an attribute called self.validators, which is a list of all the validators it has, calls each one, traps the validation errors, collects all of the error messages, and then raises a new validation error with a single list of all the error messages that came out of all of the validators on that field. Which raises a question of what validation approach do I want to use? Use the toPython method of the field when validation constraints are tied to your data type. Usually this means data types that are a number or a type of number, and it's whether you can convert it to the appropriate type that makes it valid or not. Validate is something you want to use when the constraint is intrinsic to the type of field you're looking at. Usually this is choice-based fields where you need to validate that what you got was a valid choice. Validators themselves should be used liberally and on any other type of validation that didn't just get mentioned. Most of the time, it's really, really easy to use validators. You can just reuse one of the built-in ones. If not, writing your own validator is still less code than writing your own custom form field type. Each one of these also carries its own error messages. You can supply your own by, for example, raising a validation error. There are also, on each and every field class, there's a dictionary of standard error messages. They're keyed. The documentation tells you what keys exist in there. Those are combined with any other additional messages that you pass in when you create a field. That dictionary is called error messages. Every form field type has two of them built in automatically, one called invalid, one called required. Basically, fields can define, any form field can define other keys. Documentation goes over all of them. This is pretty much what it looks like. Let's say you wanted to pass your own error messages into this field. This is how you would do it. Build your error messages dictionary, pass it when instantiating the field, and now it will use these messages automatically instead of its own defaults. Each field actually has two default widgets that go with it. One is called widget, that's the standard one. The other one is called hidden widget, which is used for when that field is a hidden field in a form. You can override these when you're setting up a form field by passing the argument widget. There's also a widget-attrs method, which returns the attributes to apply to that widget. Remember when we saw there was a method that pulls in extra attributes? This is the type of thing we're talking about. Keyword arguments on fields, there are some common ones that it's good to know about. Required lets you say basically whether the field is required. There's a label field that when you're outputting the form automatically, this is the label you're going to get in the HTML. There's a help text field that lets you, basically same as in the admin. Has everybody used help text in the admin? Basically same thing there. When you're outputting your form, that will show up for that field. There are two special field types that correspond to models. Model choice field, model multiple choice field. Model choice field is how you get basically a foreign key. Let someone choose a single instance of a model. Model multiple choice field is what you'd use for like a many-to-many field, where you need to choose multiple instances of a model. These are kind of special because choice fields all take a list of choices. These take a query set. They will return the actual object chosen from that field instead of any other Python type. Just as there's a multi-widget, there's also a multi-value field, which can wrap multiple fields into a single unit. Where multi-widget had that decompress method that could, say, split a date-time instance into a date and a time, multi-value field has a compress method that does exactly the opposite. Standard example there is split date-time field, which uses a split date-time widget. There's also localization. This was a really big win as of Django 1.2. We now have this whole built-in localization system that knows things like, in your locale, do we use commas or periods to group numbers? In your locale, how do we format a date? Do we put the month first? Do we put the day first? Do we put the year first? All of this information is available, and the form system is aware of it. Most of it you will find in django.utils.formats. Has calendaring. For the most part, you don't need to mess with it because all the form fields automatically pull it from the active locale. If you're writing your own custom forms, go look at the documentation for localization, see how the formatting tools work, take them into account when writing your own custom fields. It's never too early to start thinking about that stuff. So widgets and forms, or widgets and fields together, make up forms. Forms composed of fields, validation, error handling, rendering, and for model forms are composed of saving. Forms use a meta class called base form. This is kind of contentious. Base form actually isn't quite necessary, but it's there anyway. You can use this directly if you want to as well. Basically, base form makes sure that all of the fields you defined on the form end up in a dictionary called base fields. Then when you instantiate one, it sets up a dictionary called fields, which is unique to the instance. Why do we have two of these? There's a good reason. If you reach into a class and change base fields, you are changing what the fields will look like on every instance of that class that gets created after that point. If you reach into an instance and change fields, you're changing only what's on that specific instance. Sometimes each of these is a useful thing to do. That's why they're separate, and that's why there's two different things to tinker with. If you know about this, you can actually build a form the hard way. If you know how Python's type mechanics work and how Python constructs classes, you can do this and end up with the same result as if you had defined something inheriting from forms.form. Not always a useful trick. Sometimes it is. I wrote a blog post a couple of years ago exploring a time when this is useful. I think it was called "So You Want a Dynamic Form." That would be the string to look for in Google. Form itself basically is set up to let you declare fields the same way as on models. There is a meta class called declarative fields meta class. This is how we ultimately get to base fields. One important thing to note, if you just instantiate base form directly, like in that previous example, you may not get the fields in the order you're expecting. If you subclass from form, declare your fields in the order you want them, Django will preserve that. This is because Django is able to do some tricky magic in the meta class to keep track of what order the fields were instantiated in. Basically, actually has a little counter inside each form field that it knows I was field number 1 to get instantiated, I was field number 2 to get instantiated, and can keep track of them to keep them in the order you defined them in. Otherwise, they end up in a dictionary which has no defined natural ordering and can look kind of random. So this is how to do the same thing as that previous code sample, but the easy way, by actually subclassing form. The most important thing you do with a form is bind data to it. The way you do this is you instantiate the form class with some data. The actual arguments are called data and files, so that you can pass in your post data, you can pass in your file data that got submitted. Looks like this. What this results in is a bunch of bound fields. Bound field is a class that exists in the form system. Each one refers to a field instance on the form itself, and the field's name in that form. And this is how, once we get that data from the widgets, pulling everything out of the submitted data, this is how we know what goes with what field is looking at what. Iterating over a form that has been bound to some data will yield the bound field instances, which is not always an important distinction, but does change the way they look when you're rendering. This is where we start getting into form validation. The way you do this is by calling the isValid method of the form. It's going to return true or false. Short circuit, if it's not bound to any data, it returns false, because a form with no data is not valid. Form validation, again, is a multi-step process. First thing we do is we call a method called clean fields. Under the hood, all this does is run through every field in the form. Remember, we went over that field validation process, just does that for each one of them. Then the form as a whole is validated. Then, if valid, that form instance gets an attribute called cleaned data. If not, it gets an attribute called errors. Clean fields just loops over self.fields, which is the dictionary of fields for that instance. Each widget attached to a field gets the data out of the data dictionary. Field is validated. Custom validation on the form is called. This is kind of tricky because you can't actually do field-specific validation defined at the form level. If you define a method named clean underscore and then the name of a field on your form, we treat that as validation for that field, the same as if it were directly attached to that field instance. This will have access to cleaned data. It will get to see whatever came out of the original field validation process, but it will not be called if the field's own clean method has already bailed out with an error. Clean form is our next step. This calls the form's own clean method. You can implement clean on the form to do form level validation. If you want to compare multiple fields, the traditional example here is you want user signups. You have a password field and then another password field, and you want them to type it twice. You want to make sure they typed in the same password each time. This is where you would do that. You can access cleaned data again. Field values are not guaranteed to be in cleaned data because it may be that some of the fields have already been found to be invalid and so don't have anything to put there. This is going to raise some form level errors. There's a special key in the form's error dictionary for this. It's _all. It's also accessible via a method on the form called non-field errors. Errors themselves are stored in instances of error dict, which is fun because each error in there is an instance of error list. So what you end up with is a dictionary where the keys are names of fields or the special form level key all. And each one of those is an error list because error list and error dict both know how to print themselves as very nice HTML, which saves you a lot of trouble and lets automatic form rendering look as good as it does. Form display itself, default string representation of a form is as an HTML table, so the same as calling the asTable method. You can also get it as an unordered list or as paragraphs. One tricky thing is they do not output their containing elements for tables or lists. They do not output their containing form elements or the submit buttons. So if you are writing and displaying forms, be aware of that. The fun part of form display, though, is this method called HTML output. This is a private method. It's undocumented API, so it's not necessarily guaranteed to be stable, but basically just takes a whole bunch of strings with placeholders. Field attributes, error messages get interpolated into this, and this is the method that bit by bit builds up the HTML of the form. So if you ever want really fine-grained control that you can't get any other way, and I don't recommend doing this because there are other ways, this would be the method to go override. It's really kind of scary, unfortunately. So there are easier ways to fine-tune the displays. If you iterate over the form, you can get the bound field instances. They come out in the right order. Very easy to work with. You can customize, you can show, inspect that, get things like label, ID, bound values, whatever you want out of it for very nice form display. You can also use dictionary style access on the form. Using field names will get you back the bound field instances. So hopefully you should never have to go as low level as tinkering with the HTML output method, because you can just do this. By default, bound field uses the field zone defined widget, but it does have a method called asText, has a method called asTextArea, has a method called asHidden. So if for some reason you want to, on a per case basis, override what widget is being used without changing the definition of the form, this is a way you can do that when you're rendering it. There's also asWidget, which lets you supply whatever widget you want. Some other things you can do, there's an isMultipart method. I recommend calling this anytime you have a form you don't know about, because the form may need to have some additional HTML to accept file uploads. IsMultipart tells you whether you need that. There's also a visible fields and a hidden fields, which do pretty much what they seem like they should do. Hidden fields and visible fields are kind of a newish, like they've been around for several Django versions, but most people don't play with them. Has everybody here actually used hidden fields at some point in a form? Okay. I won't spend too much time going over the fact that those are kind of fun. Anybody have questions about like how those different components work together before we look at them in the context of model forms? Yeah.
What would be a good way of doing of rendering a read-only field? You know what I mean?
Of a read-only field? The good way to render that is not as an HTML form field, because there is no way in HTML to display a form field and disable it such that someone with Firebug or a web inspector couldn't go sneak data into it.
What I mean is, because you have a widget that renders the form field and also another one that renders the hidden version of the field, I was wondering if there's a way of, preparing a widget just to show the content, not an actual HTML widget, just the content of the...
I suppose you could write a widget that doesn't actually output any sort of form elements. Personally, I would just display the value. You can get that out of the bound field easily enough. Okay, so model forms, which is probably what a lot of people like and love and work with all the time. Model forms base class is base model form and uses yet another meta class, this time model form meta class. Model form meta class is kind of fun. Basically parses the meta declaration of your model form, turns it into an instance of model form options. Anybody seeing parallels to the way we parse models in our meta class here? Stores it as an attribute named _meta on your form class. Model form options stores the model class, the fields to include, the fields to exclude. Hit the button too quickly. Also stores a dictionary of field names and widget instances to override the default widgets. Has everybody actually seen this feature? This was new a couple versions back. It's really, really handy. If you go look at the model form documentation, there's a bunch of ways you can override things in the definition of the model form. This is where they all end up getting stored. The way we actually map the fields is we go look up each model field. Remember, each one of those has a method called form field. You can override that on your model form by defining a method called form field callback. Basically what this does is it's called for every field in the model, or every field in the model is going to end up on the form. Gets past the model field class and any widget from the form class that was already set up. What you're allowed to do there, you can just pass back that form field class if you want to by calling form field on the model field class, or you can go in and put whatever else you want. This is really handy if you don't want to spend a lot of time, like if you have a big form with a bunch of fields and you don't want to override each one of them individually, you can write a form field callback method and do it that way. Field values to go into the form. There's a method called model to dict. Uses each model field's value from object method. We had that a little while back in one of the examples of model introspection. There is some special case handling there for many-to-many fields. Validation of a model form actually uses the model's validation routines in addition to its own. Does not keep track of validation on any model fields that aren't in the form, and excludes any model fields which already have errors as a result of form validation. Saving a model form, there's two methods, save instance and construct instance. The reason that there's two methods is that sometimes we have an existing instance of the model that we're working with, sometimes we're about to create a new one. They're actually slightly different logic depending on which case we're in, so we have two methods for that. Each model field actually also has a method called save form data that gets a piece of data from the form and knows how to put that in as the value of that model field. File-based field saving has been deferred, basically because we want you to have the ability to choose where to save the file based on other field values in the model. So keep in mind that that's generally the last thing that happens during saving. Anybody have any questions about that? Hopefully, that makes a little bit of sense as to how a model form works now that you know all the components. Form media is one of my favorite features of the form system. There's a media class in Django.forms.widgets. Has two attributes, one for CSS. It's a dictionary, basically. Keys are all CSS media types. Values are paths to style sheets. Also has a method called add CSS that you can use to stick those in there. Basically avoids adding duplicate style sheets. You can stick the same style sheet in there as many times as you want. It will only come back out once. Also has a method or an attribute called JS, which is just a tuple of paths to JavaScript files. JavaScript added by a method called add.js. Again, checks to make sure it doesn't add any duplicates, so if you call multiple times adding a JavaScript file, it only goes in there once. This is useful for bundling media. You can do this on widgets, you can do this on forms. By defining an inner class named media, same way you would define meta on a model or on a model form, define those CSS and JS attributes, put things in there. Here's an example. Let's say we have two JavaScript files that we want to have with this widget. That's all we have to do for it. How it ultimately works is there's yet another meta class. Media defining class parses the media declaration, except on forms where the declarative fields meta class does this. Gets out those media paths, which can be full URLs with domains, can be relative URLs, or can be file names, and they will be interpreted as relative to your static URL. There's also a method called absolute path on the media class that helps figure this out. Rendering these, basically, the string representation of a media instance is the correct HTML for including all style sheets and JavaScript files named in it, which is really, really handy. Dictionary access also works. You can get the specific JavaScript or CSS out of it. Render is the method which spits out all of that. There's also a render CSS and a render JS that do pretty much what they seem like they should. Unicode representation is everything. Media and inheritance is kind of fun. Subclasses of widgets inherit their parents' media definitions. Subclasses of form inherit the parents' media definitions. You can specify extend equals false in the subclass media class to stop it from inheriting. You can also combine media. It's actual simple addition. We've implemented the proper methods on this. We will weed out duplicates when you do this. So this media plus that media is just going to be the union of all of them minus duplicates. You can use media outside of forms. You can make your own. Anytime you have a class that you're going to display that you want to include some media on, this is how you would do it. Simply write your own class, give it a meta class of media defining class, and then whenever you write subclasses of that, you can define an inner class media and it just magically works. We use this in a few places. The admin actually also uses this so that you can get admin media. Anybody have questions about any of that? Yes?
Probably a really naive question, but is protection from cross-site scripting and JavaScript protection
What do you mean? As far as like protection from cross-site scripting in the form system, yeah, same as with templating, everything gets escaped. Anything that's not the developer, like your initial values that you supply as a developer, I think actually also are escaped. Basically, we don't treat anything as safe. Our view is that the world is out to get you, which usually it is. Okay, so remember I said this was going to be lighter and easier going forward since the ORM is big and scary. That's basically everything you need to know about the form system to be able to work with it effectively, even under the hood. So let's talk about templates. Major components of the template system. It's the template class itself, tag and filter libraries, template loaders, template loaders are the one that nobody ever talks about, so we're going to focus some time on that because that's the low-level guts, and that's something that actually you can do useful stuff with. Template loader basically has the job of locating a template wherever it may be and compiling it into a template instance. The base class here is django.template.loader.baseloader. You'll notice that there are also other loader classes that subclass from this. Basically, the method we care about, load template source, and reset. Most custom template loaders you write will override load template source. This is the method that's required to go out and actually find somewhere some string that we can treat as a template. Loaders which care about caching or thread state should also override reset. There is a caching template loader that has to care about thread safety issues. It uses this to make sure it doesn't run into any problems. Load template source basically returns a tuple of two things. One is the template source, which is a string. One is origin, which is, hey, where did you get that from? There's a file system loader, for example, searches through your template directories, returns the file path as the origin. App directories loader, same thing. There's an egg loader that looks inside Python egg files and returns the egg name as the origin. This is where you can get into other template languages, because a template is really just a method that defines, or is really just an object that defines this one method. We don't really care beyond that, whether it's Django template, Jinja template, Genshi template, anything you like. Which means if you can write a wrapper around your own template system that implements that method, and write a loader which knows how to go out and find a template from your template system and build this wrapper object, you can use any template system you want in Django. It's usually, I think, about 6 or 7 lines of code to use Jinja templates instead of Django templates by default. It's a little bit more to use Genshi or Mako or other systems like that. This was new in 1.2 or 1.3, I forget which, but is really, really handy for using any sort of other template language. This is covered in the documentation, by the way. If you go into templates, I think on the template API page, it explains how this works and has an example. The template class itself is django.template.template, compiled usually from a string source. What this is ultimately is a wrapper around a list of template.node instances, and actually that's a class called node list. How many people have written their own custom template tag before? Most of you? Okay. So you at least have some idea of what we mean when we talk about a template node. We're going to get into that in detail here. Compiling a template, basically, there's a lexer, breaks the source string of the template down into tokens, which are represented by the class django.template.token. Django.template.parser turns the tokens into node instances and then finally returns a node list. Lexing process is regular expression based. As much as we hate regular expressions and as much as they are the wrong way to lex and parse languages, this is how we do it because it works. Uses defined constants. Basically, just give it a source string and an origin, you will get back a list of token instances. Tokens themselves are django.template.token. Each one knows its type and knows its contents. The Token types are text, variable, comment, and block. Comment isn't that interesting. Variable's kind of obvious. Text is any literal text in a template. Block means a template tag. From Django's point of view, anything that is a template tag is considered a block token. It has a method called split contents that keeps template syntax in mind as it splits them up into a list that you can use. The parser itself, basically you instantiate it with a list of tokens. You're going to get back a list of nodes. Parse is the method specifically that turns the tokens into a node list. And now we get into the meat of it, Django.template.node. Everything that is in your template, every bit of text, every tag, every variable, every filter call, ends up as an instance of some subclass of Django.template.node. This is the heart of the system. Every node must define a method named render, which takes a context instance and outputs a string. It could be an empty string, but it has to be a string. Node list is simply a list of node instances. The way we render a node list is by iterating over all the nodes in it, calling render on each one, and putting the results together. This is what happens when you render a template, is basically by the time we get to calling that method, we've got our node list, we know what our context is, we're just going to run through the whole thing, jam all the results together, and that's the output. Mapping tokens to nodes is done by the parser itself. Plain text and variables become text nodes and variable nodes, which are pretty simple. Variable nodes just resolve themselves, text nodes just output themselves. Comments just get skipped. They don't actually map to any node type. All other tokens are treated as tags that get looked up by their names. The way we handle tags is the parser has a dictionary called tags, maps the tag names to the compilation functions. So in that part of the Django documentation, when you write your tag compilation function, this is what ends up in that dictionary. Every time you load a new tag library using the load tag, we go out, find that library, find all the tags in it, stick those compilation functions into this dictionary and update it. Built-in tags and filters automatically show up. Django.template.builtins is what we consult to see what we should load by default. There's a method add to built-ins that you can call if you have your own particular template tag libraries that you want to be always available without having to use a load tag. You can do that. By default, it's just Django.template.default tags and default filters, which are pretty obviously named modules. Tag loading itself is keyed by module name. What we do is we go through and we look at every application. We look and see if it has a module in it named template tags. We look and see if inside of that is a module with the library name you're asking for. If that works, that's where the library comes from. If it doesn't work, we raise an exception. First app to have a library of a given name ends up winning. The parser is kind of fun to play with. If you've done the documentation part where we go over how to write a tag compilation function, you get access to the template parser and you can play with it in there, which means you can parse forwards and backwards in the template. You can look for specific other tags in the template. You can call the parse method, which does take an optional argument called parse until. It takes a list of tag names and it parses up until it encounters one of them in the template. Specifically a token of that name, because those are tokens at that point. You can also call parser.deleteFirstToken to delete whatever token is at the point where you are right now. This is really useful for tags that have to have multiple parts and want to clean up after themselves after they've figured out what they're supposed to do. There's also a method called nextToken, which is usually what you do after parsing until something. Returns you the next token in the template. This is used by the for tag. Has anybody ever used the empty syntax on the for tag? This mimics some Python syntax. Basically, you can write your for loop, and then you can also write a clause called empty, which is what to do if whatever sequence you fed it didn't have anything in it. If is the same way. You get if else. Basically, this combination of parse until and then look at the next token, you find out, okay, I'm parsing an if tag. Am I seeing the else or am I seeing an end if? Basically lets you figure out whether to keep parsing or not. If you want a good look at this, go look at the Maybe not necessarily the if tag, because that's kind of scary. But look at the way the for loop is implemented in the Django template language and the built-in tags. You'll see a lot of fun little parser tricks you can do. You can also skip past, which takes a tag name and lets you go to just beyond the next time that occurs. The comment end comment syntax works this way. This is how we skip comments. When we see a comment tag, we just skip until we get past the next end comment tag in the template. Debugging. Debug equals true in your settings. We'll swap out the lexer and the parser for debugging versions, which can do some fun tricks. I think I've got a slide out of order here. Yeah, we'll talk about the debug parser in a minute, probably in about 3 slides, because I think I know what I did here. Things you can do while parsing. Your node classes can set an attribute called must-be-first. The extends tag does this. It is a syntax error for a node with this set on it to not be the first node in the template. The debugging parser uses enter command and exit command. These are methods that get called every time the parser begins or ends processing a tag. The debugging parser uses this because it cares about where it is, so that if there's an error, it can say, I hit this error inside this tag. You have access to this as well. You can use it for logging. You can use it to tweak parsing based on what type of tag you're in, all sorts of fun things. Template variables. Documentation covers this pretty well. It's variable node. Internally is wrapping something called filter expression. A filter expression is basically a variable name plus any filters that are being applied to it. Filter expression checks that all the filter names are valid, either built in or from a tag library that's been loaded. Wraps the variable in a variable instance, if possible, if necessary. Variable itself is what is responsible for actually resolving the variables. It also understands getText syntax. Did you know you can use the little underscore parentheses syntax in a template and translate things automatically inside a variable? We support this out of the box. We also support numeric literals, both floats and integers, and some scientific notation and some other kind of weird things that if you go read the way a variable tries to resolve itself, you will see. But really, all of the meat happens in context. Who here thought context was a dictionary? Nope. Context is actually a stack of dictionaries. And there's a reason for this. Gives us fall-through lookup semantics. Whenever we are going through a context, lots of tags, in particular the for loops, will push new dictionaries onto the top. The way we resolve a variable is we look in the topmost dictionary on the stack. If we don't find it, we look in the next one down, next one down, next one down. Eventually we error out. This is really important, even though it sometimes slows down processing a little bit, because it means a tag like the for loop can set all of the special variables that it wants to set. What iteration are we on? Are we on the first? Are we on the last? Can set all of these variables safely in the context, and as soon as it finishes processing, it can pop that top dictionary off the context stack, and those variables go away. The with tag does this. Anytime you use with and end with. When you hit the with tag, we pop a new dictionary onto the context, put that variable in there. When we hit the end with, we take that dictionary off the stack, all those variables go away. This lets template tags create temporary variables in the context that you may or may not need. For loop needs it, with needs it, and then safely clean up after themselves. So there are some tricks you can do with this. Context has a method called push. New variables, as they're being set, are added in whatever is the topmost dictionary. You can pop that back off, and all those variables go away. There's also a render context. So it's added fairly recently. Render context is thread safe. It's there for nodes which need to save state from one moment to the next. And this happens sometimes that when a node is instantiated, it needs to care about some state that will be retrieved later when it's actually being rendered. Render context is also a stack of dictionaries. Only the topmost actually gets checked for variable resolution. And there is a render context attached to each and every context instance in Django. So basically every time you render a template, you get one of these, and any template tags that need to store state but may run into thread safety issues can take advantage of that. New dictionary gets pushed onto the top at the start of each render call, popped off at the end. Auto-escaping is also, oddly enough, as we'll see in a minute, part of the context. By default, as everybody knows, every variable in a Django template is escaped. There's a filter called safe that turns this off. There's also an auto-escape tag that can turn this on or off. There's also an auto-escape attribute on a context instance. I don't recommend you ever do this, but you can actually set that to false and turn off auto-escaping on a per context basis. For the most part, that's everything you need to know under the hood of the template system. Unless there are any questions or anybody has something they thought I missed. Anybody still confused about how templates work? Yeah.
Could you describe some best practices or some pitfalls of using safe? You see people that are using it just way too much, or
Honestly, I haven't seen people using it too much because the first time they encounter auto-escaping and they realize what it's there for, they actually stop and read a bit. I've never seen people overusing safe or, just turning off all auto-escaping to get around it and then getting owned by something. I'd like to think this has been a pretty successful thing. Personally, I don't use safe all that much. I think, actually I had to, in an application fairly recently where I knew that the only strings it was dealing with were being supplied through the admin by people we trusted. I marked them as safe, but I think that's the first time in a couple of years that I'd marked a string as safe. I just normally auto-escape everything. So, any other questions about the template system? Okay. Yep. You want to know if we're working to improve it? Working to improve performance on the template system? There have been some efforts. We've gotten one or two decent speed-ups in the past. For the most part, the Django template system doesn't aim to be the speediest thing on the planet, because when you measure what actually goes into processing a request and sending a response, it's like, template processing and maybe form processing and maybe a couple other things, and then talking to the database. It's just not enough to be worth that much effort, though there have been some things to try and speed up the language. You can also use Django, which does some really interesting tricks to be similar in syntax but a whole lot faster. Personally, I don't obsess much about the speed of the template system. So others might. Patches are always welcome. If you can make our template system 5 times faster without losing functionality, I'll be happy to take that. Yeah.
one of the problems I hit sometimes is you have a dictionary and a template variable, and then maybe you want to have another for loop and another variable where you want to get an instance of that dictionary. The key is another variable.
Okay, so accessing something in a dictionary where the key is a template, where the dictionary is a template variable and the key is also a template variable. That's not something that's easy to do. I would say probably you end up writing your own tag for that. It's not that hard. Maybe down the road we'll add support for it. Okay, so coming down to the end, we're going to talk about request response processing, and then we're going to talk about the admin, which is going to pull all of this together. Everybody have a basic idea of how HTTP works. We know the idea of HTTP request comes into the server, response goes back to the client. In Django, we do this with handlers. There's a base class called base handler. This implements our basic request response pipeline. We have 2 subclasses right now, and actually 3, but one of them needs to be deprecated. We also have a mod Python, which is deprecated, and we have WSGI, which going forward is going to be the standard request response handler for Django. because really there's no reason to be running Python web applications under anything other than WSGI. Basically, the call method of the handler, it is a callable object, is the entry point for Django. This is where Django starts. That method loads the middleware, initializes an HTTP request object, and then calls the getResponse method of the handler. GetResponse is what the handler subclasses usually, I think ModPython overrides it, but WSGI doesn't, or the other way around. Middleware loading is done in a method called loadMiddleware. Populates attributes for the request, response, view, and exception middlewares. We initiate our HTTP request. Base class is django.http.http request. Again, we have subclasses, one for ModPython, one for WSGI. Going forward, there will only be the WSGI one. If you're using ModPython for some reason, and if you are, please stop. There is an attribute on the request object called REQ with an underscore in front of it. That's the raw ModPython request object. If you are using WSGI, as you should be, and if you're not, start using it. There's an attribute called environ, which is the WSGI environment in which Django is invoked. So if you ever need to access that low-level stuff, it's in there. GetResponse is where all of Django's processing actually happens. First thing we do is we apply our request middleware, resolve the URL, apply the view middleware, call the view, apply the response middleware, and hopefully return a response. This is all covered in the documentation, but now we're going to go into actually how it works. So we need to resolve a URL. Django.core.urlresolvers.setURLconf sets the root URL configuration. This is thread local. We get this basically from root URLconf, but you can override it if you need to. Regex URL resolver is the class that actually performs the resolution. That class is kind of funny. You instantiate it with the string name of your root URL configuration and call resolve, passing in a URL path to resolve it. It will return a tuple of view, positional arguments, keyword arguments, or it will raise URL resolvers.resolver404, which is a subclass of Django's own HTTP 404 exception and will be handled correctly if you raise it. Basically what this does is goes through a list of regex URL patterns, which when you set up your URLs, and you call that little, patterns and pass it a list of stuff, this is what you're creating. Each one of them represents a single URL pattern. Each one of them has a resolve method, which takes a path. Each one of them says, do I match this path? And returns a tuple of the view, positional arguments, and keyword arguments if it does. Resolution errors basically go through resolver 404. The handler will detect this. If it sees a 404, it will call the resolver's resolve 404 method. This also works if you raise an HTTP 404 from the view. 404 handlers are specified by the root URL conf of your project. You can set an attribute called handler 404. The value of this should be the complete path to a view. By default, it's django.views.default.page.not-found. Probably you don't need to change that. Hopefully, once we've resolved this, gotten past URL and gotten a view, how does a view work? Django views have exactly 3 requirements. 1, they have to be callable objects, which means they can be functions or they can be callable classes. 2, they have to accept an HTTP request as their first positional argument. 3, they have to either return an HTTP response or raise an exception. That is literally the definition of a Django view. You don't have to do anything else beyond that. Simple views are just Python functions, and in fact, most of the views you've probably written are just Python functions. 95% maybe of views in the wild. Class-based views are a possibility. This is simply an instance, a class whose instances implement the special method call, which lets you call them. Basic support for this was added in Django 1.3 for making it really, really easy to write your own class-based views. The base class for that is django.views.generic.view. What this does is implements the basic callable mechanism and implements dispatch on HTTP methods. So for example, if you have methods named get, post, update, delete, depending on the HTTP request method, those methods will get invoked. View also implements a method called asView, which is what actually returns you a callable object that you can put in your URL conf. Some of this is covered in the documentation. Unfortunately, it's not that great yet, but I'm working on it. Class-based generic views were added. Basically, it's a whole system with a bunch of subclasses and mix-ins. For the most part, you just figure out which subclasses you want, subclass them, declare some attributes and some methods to control their behavior. For example, if you subclass the object list generic view, you define a method on it called getQuerySet that defines the query set it will pull the list of objects out of. A lot of it is just that simple. There are also other class-based views in Django. One object can be multiple views. One object can provide its own URL patterns and do its own internal URL dispatch. This is actually how the admin works, as we're going to see in a minute. Ultimately, the goal is return an HTTP response. Again, this lives in Django.http. Thankfully, this time, we don't have to have a WSGI response and a mod Python response, because the way this works is we return an HTTP response, and whichever handler we're on will actually take that response and convert it into whatever is appropriate for the gateway we're using. So for example, if it's a WSGI response, it will, invoke the start response handler with the correct data and then go from there. So you don't have to worry about that too much, which is why you can just directly instantiate HTTP response and not worry about it. HTTP response itself, however, does have subclasses for different status codes. Basically, we support custom subclasses for all of the following codes: 301, 302, so for redirects, 403, 410 are usually handy, 410 gone, 403 forbidden, 500 internal server error. We have special case classes for all of those. It's easy to write your own as well. Just subclass HTTP response and change the attribute status code to what you want it to be. The way we handle errors there is most exceptions will cause the exception middleware to be invoked and applied. One exception to that is we do not trap system exit. This is an important thing in Python programming. We never trap system exit. Python programs that try to do that are bad. Exceptions to our exception policy are anything raised during the exception handler will not, or during the exception middleware will not be necessarily handled by exception middleware. Any exception raised in a 404 handler will not be handled by exception middleware. Ultimately, where we end up is in the HTTP handler's method handle uncaught exception. What that will do is look up the attribute handler 500 on your root URL configuration. By default, this is the view django.views.defaults.server error. This deliberately uses an empty context and the template 500.html. We've had people ask before about this, adding something to the context there. The basic assumption is, in this view, we know something has gone wrong. We don't get to know in advance what's going to go wrong. We're not going to trust that any part of Django works. We're simply going to spit this back out with an empty context and say, it's up to you to say internal server error, we're checking our logs. Middleware can do some of this stuff. Basically, middleware methods, request middleware, view middleware, and so on. Each one of those can modify the request or response as appropriate, depending on what they get. They can return none, or they can return an HTTP response. This is a fun thing because if a middleware returns an HTTP response, it can short-circuit the rest of the pipeline. As soon as we see a response object come out of a middleware, we just stop processing and return it. They can also raise an exception, in which case we will short-circuit out of the rest of the request processing and go straight into exception handling. So you can, if you want to, use middleware to just completely short-circuit the process of handling a request in Django. Middleware calls basically process request middleware methods get called just before URL resolution takes place. Process view methods get called just after that. Process response gets called just after the handler's getResponse method finishes. And exceptions obviously shortcut straight into process exception whenever they happen. There are also some signals that get sent. There's a request started signal. There's a request finished signal. There's a got request exception signal. So if for some reason you want to do processing that's not in middleware, or just listen for or log these sorts of things, you can listen to these signals and do it. That's basically as in-depth as we can go into HTTP request response in Django and middleware and URL resolution. If you want to, you can read the code. It doesn't get a whole lot more complicated than that. Anybody have specific questions about it? Yeah.
A question about the class-based views.
Yeah.
Have you gotten it so that it plays nice with decorators?
That's an ongoing issue. So the question is class-based views and decorators. And there's a problem because the way you decorate a function in Python is different from the way you decorate a bound method of a class. Right now, there's some debate. I don't think we actually have a unified handler yet, but I believe we do have tools so that either way you can decorate things. I just don't think we have a simple, it all works one way system yet. So that is something to be aware of when you're writing a class-based view. If you need to decorate it, you need to change how you decorate it because it's a class-based view. Yep.
When you have a set of code that you want to execute only on the application launch,
Like when the server first starts up, there is nothing in Django for that, pretty deliberately, because ideally your server is going to be cycling processes in and out, and every request should be the same as every other. So Django does not provide a mechanism for that. In general, there's some things you can do that, like, if you have a particular module that does something, you can have it check when it's first imported, hey, has this cache been set up, or has this data structure been populated? And if not, do that. But there is no high-level API in Django for determining, hey, when did this process start and did we do this stuff? It's really something that's sort of out of scope of what Django can do.
so I have one custom middleware, and then I have those sets of code in it. Would that be a bad idea?
I mean, you can do it in a middleware like that. The way I would probably do it is just in an init.py inside an application, because that's guaranteed to get imported very early. Traditionally, when I've had to do that stuff, that's where I do it. Because when Django starts up, we have to look at your list of installed apps and import everything anyway. So that would be one place to do it.
Can you just elaborate a little bit more on when you want to use a class-based view versus
When to use a class-based view versus when to use a function view. This is something that I'm not sure I have a good answer for because I still haven't worked as much with class-based views. Generally, I think if you find yourself writing a view as a function and starting to put like more than one or two keyword arguments that it can take, it's time to start thinking about whether this is a class that you should be subclassing and overriding. Basically, I've seen myself end up with these laundry lists of keyword arguments in views, and it's not fun, and it's not pretty, and things that would be much cleaner as classes where you just subclass and override. Basically, once you get beyond one or two keyword arguments to customize how it behaves, I'd say that's when you need to look at class-based views. Yep.
The request object passed to a view has a ton of useful information.
Yeah.
The metadata that comes from Apache. Any best practices? I did one thing because instead of having to pass that request object to every method that you call inside your view on the model, because I was doing it for logging.
Yeah.
Is there any best practices to avoid doing that? What I did is I wrote middleware to copy that request object into thread local storage. I wondered if that a good or a bad because it meant I didn't have to pass the request object in the signature of every method called from the view.
Okay, so the question is how to avoid, having to write a bunch of methods and functions that all take a request object and having to pass it all over the place.
Or maybe that happens.
I may be the wrong person to ask about this. I am the reason that the original wiki page on thread local storage of requests got blanked and then locked, because I have been on such a crusade against that. Personally, my opinion is that it's not a bad thing to be explicitly declaring that you take a request and explicitly passing it around. It is more work, but I would rather, the way I do things, I would prefer to see the request, where it's going, where it's being passed around, rather than put it into storage and be accessing it and not know where it's being accessed. I like to be able to watch that control flow. So personally, I wouldn't do it. Ask a different, committer, you may get a different response. Anything else on request response? Okay, last section, the admin. Mostly we're going to talk about this because it's something that people seem to care a lot about. I don't know why. They think it's some sort of cool feature. This is basically everything we've talked about is relevant here. Admin basically is made up of admin site, which is a class that represents your admin interface, knows which models and which actions are registered with it, and you can have multiple admin sites active on a single Django installation. I've done this. It works. It's not the best thing in the world, but it works. Admin site basically has a property called URLs that delegates to a method called getURLs. This is how the admin site, when I mentioned class-based views earlier, I said, a class-based view can do its own URL resolution. The admin does its own URL resolution. You will actually see, if you look in there, the same import and URL patterns equals and all that stuff that you would see normally in a urls.py is being done in this getURLs method. Auth checks on it for login, logout, everything are implemented as methods on admin site. But otherwise, everything happens in model admin. Model admin is where the good stuff is. High level, this provides admin options and acts as a set of class-based views, which is kind of fun because a model admin is one object that happens to implement a bunch of different views. It also uses the media defining class metaclass. So if you want to, you can define an intermediate class on an admin. Has a lot of class attributes for customization. They're all listed in the documentation. You can override templates, you can override forms, you can override form fields. Again, Django's documentation covers most of this, but not all of it. So we'll mention a few things. You can override these attributes on a model admin, add form template, change list template, and so on. Changes the templates that particular model admin will use. Overriding forms, you can set the attribute form to a form class, or you can override the method getForm. GetForm is a little more useful because getForm gets past the HTTP request. So you can customize the form on a per request basis that way. Admin forms themselves have a helper called admin form. This is how we get those fancy, nice looking field sets in the admin. There's also contrib admin widgets, which contains all of the special case pretty little admin widgets that we've all come to know and love. Overriding specific fields you can do by setting fields or exclude on the form class you're returning. By defining your custom form class, you can also set fields and exclude on the model admin. You can also define some methods. Form field for DB field, form field for choice field, form field for foreign key, and form field for many-to-many. All of these will be called to see if you have chosen to override the default form fields the admin would use for particular types of model fields. Permission control, basically again, it's a bunch of methods, has add, change, and delete permissions. There's a get model perms method, which basically looks for a whole set of permissions. The other fun thing that people don't always realize is you can do this in the method that gets the query set for the admin. because again, you get access to the HTTP request, which means that not only can you customize the form on a per request basis, you can customize what objects you're willing to show. Logging happens in the admin. If you've ever looked at that, view history of something, method called log addition, method called log change, and a method called construct change message. These are the methods on model admin that actually output the log objects that you then see on the object history and in your sidebar. So you can fiddle with those if you want to. There's also a log deletion. The views themselves are add view, change view, delete view, history view, response add, response change, both of which are kind of funny. Response add and response change are actually where most of the add and change machinery happen, even though there's add view and change view. I forget off the top of my head why those are different, but there is a reason for it. Then finally there is change list. And if you've ever looked at this, this is the scary one. Django.contrib.admin.views.main.changelist. The fact that it's there tells you that it's not part of model admin. This is code that goes back to about 2007, maybe 2006. It is the last bit of truly legacy code in the admin, which is kind of funny because it was originally part of something called new admin back the first time we refactored it. Changelist is a gigantic, scary class that basically, whenever you are looking at a list of objects in the admin, you are looking at a change list. This is what implements all of the filtering and searching and all of those options you declare on the model admin for what fields to show. Everything that happens there happens in change list. I don't recommend ever reading it. It's not code that will make you a better programmer. It's not code that will teach you much more about Django, except to see how bad we were at this back in like 2007. You can look at it if you want to, but if you ever need to know it, that's where changelist comes from. Modeladmin.getChangelist is a method that can override that. Unless you are clinically insane, you probably should not be writing your own changelist. That's pretty much the admin. If anybody has questions about that, yeah.
I'm going to struggle to phrase this very well, but there's some sort of the admin pages that are generated. They use the same mechanism as the new. There's some mechanism for generating admin-like pages, which is fairly new to what I'm talking about.
Not off the top of my head.
I'll figure out.
Okay. Okay, yeah, if you figure it out, feel free to come find me later and ask me about it. Okay. Yeah.
Is there any support for making the admin reusable so that you can put it inside of the view?
Not really. He's asking about reusing the admin inside other views. If you want to, like, you can always call this stuff. Like, if you know the methods on model admin, you can. It's not something that's ever really been encouraged, mostly because the admin is designed around some assumptions that are not safe or secure for the general public. The admin is designed around the assumption that everybody using it is someone you know and trust and have given permission to. And those assumptions are not safe for general purpose views. Okay, that is actually all the material I have prepared. Hopefully by now, that's kind of a whirlwind. I'm going to put the slides up. There is video of this, so you can go back and watch it. My goal here is to give you an idea of basically all the parts that go into Django. And hopefully now you can kind of fit them together in your head and start seeing how something like the admin would work, or understanding how forms work, or maybe even understanding how the ORM works. And if you do, good for you, because I still don't entirely understand the ORM. If anybody has general purpose questions, feel free to ask them or come find me at any point. I'm here at PyCon today through next Thursday. And I am always happy to talk to people or answer questions. So if anybody has anything they want to ask now, we can go over that. Or if you just want to come find me later. Yes, sir.
What's your IRC handle?
It's actually printed on my badge, which is also my Twitter handle. You will see it as Ubernostrum, which is usually fairly easily recognizable even if you can't figure out how to spell it. I should be signed on right now, actually. Yeah. Anything else? Okay.